In this video, you will master the Spring Boot fundamentals. Starting with the basics, you will launch an HTTP server, learn the MVC architecture, field validation, and structure your code using a professional 3-layer approach. You will dive deep into beans and dependency injection, the core concepts that power Spring Boot. Through hands-on practice with unit and integration testing, you will ensure that your code is reliable and maintainable. And finally, you will build REST APIs with comprehensive exception handling and create clear API documentation using the OpenAPI spec. And if you want to go even deeper after you finish this course, feel free to check out the complete Spring Boot Bootcamp, which also covers SQL database integration and Spring security. The link for the complete bootcamp is inside the video description, but for now, let's continue with our current Spring Boot course and start by learning the Spring Boot fundamentals. We're going to begin by downloading the resources for this course, so I will see you in the next few seconds. I posted all of the resources for this course on GitHub. You simply have to click on this big green button, download the zip file, and it should download the resources for this course. Once you download the resources, go to it. If you are using a Mac, unzip the resources into a folder by just pressing open. If you're using a Windows computer, then you would have to extract the contents of your zip into a folder. Once you open the folder, you will see workbooks and challenges organized based on the section that they belong to. In this section, you're going to launch an HTTP server using Spring Boot. From your browser, you will make a request to that server, and the server is going to respond in kind. Spring Boot is a Java framework, so you need to have Java installed. On Google, look up Amazon Corretto. Click on the first link and choose Java 17. Not 18, 17. Java 17 has long-term support, Java 18 does not. So whatever Java versions show up for you, please choose Java 17. We're going to go over to the Mac platform, and what I want you to do is go to your Apple menu, About This Mac. If you see M1 or M2, then you have a MacBook with Apple Silicon, so you will choose the download link that corresponds to this architecture. If it says Intel here, then you have the x64 chip architecture, so you would choose the download link .pkg that corresponds to this platform. Alright, I have a MacBook M1, so I will choose the following download link. Shouldn't take very long to download. Press on it. And now just go through every single step in the installation wizard. Put in your computer password. And that's all. Once you're done, close the installation wizard and open up a new terminal. If your terminal was already open, please close it and open a new one. Once you do, write java-version. And you should get a Java version of 17. Before we move on, I want to mention that some of the projects in this course use Java 11, but Java 17 is backwards compatible, so not to worry. As long as you have Java 17, whatever project you end up loading from our course resources, you should be just fine. Because this recording is for Windows, go to the Windows platform and choose the following download link. Shouldn't take very long to download. Press on it. And now just go through every single step in the installation wizard. And that's all. Now from your start menu, go ahead and launch your command prompt or PowerShell, whatever you prefer. And if you, by some chance, already had your command prompt open, please close it and open a new one. And here I'm just going to write Java-version. And you should get a Java version of 17. Before we move on, I want to mention that some of the projects in this course use Java 11, but Java 17 is backward compatible, so not to worry. As long as you have Java 17, you'll be just fine. You will be able to load and run all of the projects in this course. In this lesson, we're going to download VS Code as well as the Java extension pack. Okay, so download VS Code for whatever operating system you're using. I'm using a Mac, so I'll choose this link. And the download should not take very long. VS Code is very light. A few seconds left. All right, once your download is finished, you can go ahead and unzip the package and open it. Now we're going to be writing a lot of Java code. So if you want support for testing, debugging, autocomplete, the first thing we're going to do is download the Java extension pack. So go to the extensions tab and write Java extension pack and download the extension pack for Java. I already have it enabled and installed, so I'll give you a couple of seconds for you to do that and then we can resume. Okay, that's really it. You downloaded VS Code and now we can start using it. Spring Boot is the best Java framework for developing web applications. In this video, you're going to create a Spring Boot project. You actually need two extensions to develop a Spring Boot application, the extension pack for Java, as well as the Spring Boot extension pack. So go back to the Visual Studio Code Marketplace, and then look for the Spring Boot extension pack. There you have it. Now I've already installed it, so I'll give you a couple of seconds to do the same. Okay, once you install it, I want you to close VS Code and reopen it. All right, let's talk about the Spring Initializer. The Spring Initializer generates a Spring Boot project. The Spring Boot extension pack includes the Spring Initializer, so from VS Code, open the command palette using Ctrl-Shift-P if you're using Windows, and Command-Shift-P for Mac. And then click on the Spring Initializer. And as of this recording, the most recent stable version of Spring Boot is 2.6.7. The versions will be different depending on when you're watching this video. So just choose a stable version. In other words, choose one that doesn't precede parentheses. Obviously, you will use the Java programming language. And the group ID identifies the organization creating the project. Your group ID should be a fully qualified domain name. It should include a domain extension like .com, .org, .net, followed by the name of the organization. So for this tutorial, I'm going to create a group ID of com.ltp for learn the part. Now, one thing I want to also mention is that the group ID should always be lowercase. The artifact ID determines the name of your application. I'm going to call the application Hello Spring. Like the group ID, the artifact ID must be lowercase as well, and every word that follows must be separated by a hyphen. We will stick with the default jar packaging type. We're going to discuss packaging in more detail in an upcoming workbook. Hey, this is Rayan from the future. Before you specify a Java version, open up your terminal, command prompt or shell, and write java-version. Right now, I'm getting Java 17, so naturally I would choose Java 17. But when I was recording this video, I was using Java 11, so I went with Java 11. All I'm trying to say is, choose a Java version that matches the one you have installed. Alright, back to the video. Dependency is software that your application depends on. We will discuss dependencies in more detail soon enough. You don't need any dependencies right now. And now you can generate your project inside the folder of your choice. I'm going to generate it inside of my desktop directory. Okay, go ahead and press open. And it opens the project that you generated. To recap, you created a Spring Boot project using the Spring Initializer. Recall that group ID identifies the organization creating the project. It should be a fully qualified domain name that's completely lowercase. Artifact ID is the name of your application, and every word that follows is joined by a hyphen. Choose jar as the file type to package your application, and a dependency is software that your application depends on. There are many different parts to a Spring Boot project. Spring Boot projects have an area for source code, resources, and application tests. In this lesson, you will break down the different parts of a Spring Boot project. So the first section is the main/Java section, and it contains the source code for your project. This section of your project contains 3 subfolders that match the group ID and the artifact ID. And inside, there's an application.java file. This file is the entry point of your Spring Boot application. You need to code all of your application's logic inside this section of your project. The next section is the resources section, which, as the name implies, contains the application's resources. The resources include a static folder that contains static web content, such as images, CSS files, and sometimes static HTML files. A templates folder that contains dynamic web content, such as HTML templates. And an application.properties file, a file that configures the settings for your application. The final section is test/Java, and it contains all of your application's tests. Once again, it contains 3 subfolders that match the group ID and the artifact ID. And inside, there is a file where you can test your application. In the future, you're going to write all of your tests inside this part of your project. So to recap, you broke down the different parts of a Spring Boot project. Main/Java contains the source code for your project. Main/resources contains the resources. And test/Java contains all of your tests. There are many ways to run a Spring Boot application. In this lesson, you will learn to run a Spring Boot app using Maven commands and the run button. The first question you have to ask yourself is, where does the runtime start? The entry point of your Spring Boot app is in the application.java file. When you run your application, the runtime starts here, and it's the Spring Boot application annotation that instruments the launch of a Spring Boot app. Through the first Maven command, Spring Boot run, this command compiles and runs a Spring Boot application. When it compiles your code, the compiled classes are going to go to the target folder, and then it will run your compiled code. Before we start, you can open up a new terminal by going to Terminal, New Terminal. All right. Your project should come with a Maven wrapper. We can use the Maven wrapper to run Maven commands. So right now our terminal points to the Hello Spring folder, and inside Hello Spring we can access the Maven wrapper like so. If you're using a Mac like myself, your Maven command must follow a /. So now, from the Maven wrapper, we can say Maven Spring Boot run. As you can see, it compiles your code into the target folder. This is the compiled version of our hellospring.java file, and then it runs your compiled code. Now, a close equivalent to the Spring Boot run command would be to just press the run button. Now, you might think to yourself, forget running Maven commands, I'm just going to use the run button. Not so fast. I recommend running your code using this command, Maven clean Spring Boot run. The way this works is before starting the build, clean will remove compiled classes from the previous build. The ensuing goal, as before, will compile your code into the target folder and then run the compiled code. I can use the up key to access previous terminal commands. To our Spring Boot run command, we will add a goal of clean. And if you focus on the target folder as I run this command, you'll notice that it removes the previously compiled code. And then the ensuing goal will recompile your code into target. Beautiful. Now, the reason why I like to use Maven clean Spring Boot run is because every now and then it's good to start from scratch. Sometimes I would get random bugs that were just solved by running from a fresh build. If you successfully installed Maven in the first section, you don't need to use the Maven wrapper. When you generate a Spring Boot project, it provides a Maven wrapper just in case you don't have Maven installed. And so you can just run Maven commands by referencing the Maven wrapper itself. But if you already have Maven installed, there is no need to do that. We can just say Maven clean Spring Boot run, like so. All right, perfect. Now, from experience teaching, for every 100 people, maybe 5 or 6 people have trouble installing Maven for reasons beyond their control. It could be that they're using a very old computer, there's some sort of incompatibility. Whatever it is, I'm going to keep using the Maven wrapper throughout this course, just so that I'm accommodating everybody. But if you already have Maven successfully installed, just use it. You do not have to always reference the Maven wrapper. So to recap, you learned 3 different ways to run a Spring Boot app. Maven Spring Boot run compiles your code into target and runs it. The run button is a close equivalent. Clean will remove compiled classes from the previous build. And then Spring Boot run will compile your code into target and run it. Throughout this course, you'll notice I'll be using Maven clean Spring Boot run. client and a server communicate with each other. How do they communicate? Well, the client starts off by making a request. The server receives that request and responds. In this lesson, you will understand the client-server model. A client makes a request. A client will make an HTTP request via the internet. An example of a client is your browser, like Google Chrome, Safari, Firefox. And from your browser, you can make requests via the internet. Now let's talk about the physical server. And this is the computer, the machine that receives your request. A client makes an HTTP request via the internet. A physical server that lives on the other side of the world receives your request. Now, an HTTP server is the software that actually processes your request. Spring Boot applications have an embedded HTTP server. The HTTP server inside of a Spring Boot app is what processes a request. So if we go through the process again, the client makes a request. When a client makes a request, a computer, a physical server on the other side of the world picks it up, and the physical server forwards it to the HTTP server inside of your Spring Boot application. The Spring Boot application prepares a response, and once the response is ready, the HTTP server sends it back to the client. The response populates the client's web page. Now, what is an IP address? An IP address is a sequence of numbers that identifies a computer. There are millions of computers, and every computer has a unique IP address. The client's request needs to include an IP address because it's the IP address that identifies the server they want to access. The physical server that matches the address picks up the request. The port tells the physical server where to forward the request. A physical server can have over 65,000 ports. The HTTP server listens for requests on one of them. When a client makes a request, it needs to specify an IP address and a port. The IP address identifies the physical server, and the port number tells the physical server where to forward the request. In this case, the server forwards the request to port 8080. The HTTP server embedded in your Spring Boot app happens to be listening for requests on that very same port, port 8080. It gets the request and it sends back a response. Okay, let's look at the client-server model in action. I'm going to go to my browser and I'm going to make a request that specifies the following address and ports. And we get Google. I made a request that specifies an IP address and a port. The IP address belongs to one of the servers from Google. The request was forwarded to port 80. An HTTP server listening on that port received our request and sent back a response. The response is HTML that populates the browser. It's worth noting that in real life, nobody ever writes the full address. We write URLs like google.com. And behind the scenes, a DNS server matches the URL to an address. In this lesson, you learned about the client-server model. When a client makes a request, it specifies an IP address and a port. The IP address identifies a physical server. The port number tells the physical server where to forward the request. In this case, the server forwards the request to port 8080. The HTTP server embedded in some Spring Boot app happens to be listening for requests on port 8080. It gets the request and it sends back a response. Launching an HTTP server with Spring Boot is very easy. How easy is it? Just add a dependency called Spring Web. In this lesson, you will launch an HTTP server. The Spring Web dependency launches an HTTP server. A dependency refers to a packaged library of files, i.e. jar files, that your application can use. Now, the Spring Web dependency, what it's going to do is bootstrap an HTTP server. Now, you can manage your project's dependencies inside of pom.xml. Open your pom.xml file, and there you will find two dependencies common to all Spring Boot applications. The Spring Web dependency instruments a Spring Boot application to launch an HTTP server. So inside of a Google search, type Spring Web dependency. Actually, correction, type Spring Boot Web dependency. And go to the central Maven repository. The central Maven repository contains all of the dependencies that we can leverage in a Spring Boot application. You're going to choose a dependency version that matches your Spring Boot app. And once you do, copy and paste this dependency inside of your pom.xml file. Like so. Now, what I want you to do actually is remove the version number. On top, the version number for all Spring Boot starters is already specified. This is a Spring Boot starter, so it's going to be version 2.6.7, just like these two. And by virtue of just adding the Spring Web dependency, it's going to embed an HTTP server called Tomcat into your Spring Boot app. And the HTTP server is going to run on port 8080. So run your application by writing Maven clean Spring Boot run. And now we have an HTTP server called Tomcat listening on port 8080. Now let's revisit the client-server model from the previous lesson. The client-server model is different when you're developing the application. In the previous lesson, the model portrays a client that makes a request via the internet. An HTTP server is inside of a machine, inside of a computer, on the other side of the world. It receives the request and it responds. In our case, your browser and HTTP server are inside of the same computer. So what should your IP address be? 127.0.0.1. This is called a loopback address. It connects the request to the computer that you're using. The loopback address 127.0.0.1 essentially loops the request back to your computer. The request is made on port 8080, so then your computer, upon receiving the request from your browser, forwards it to port 8080. Your application's HTTP server is running on that port and it receives the request. So now from your browser, what you're going to do is write 127.0.0.1 so that the request is routed to your computer, and then write 8080 because our app is listening on port 8080. And we get the generic white label error page. That's because the application's HTTP server receives the request, but you didn't write any code that tells Spring Boot how to respond, so it sends back the default error page. Now, before we fix this issue, I just want to emphasize that writing 127.0.0.1 is really annoying. Localhost translates to this address, so instead we can write localhost 8080. And in similar fashion, localhost is going to route the request to the computer that you're using, and in turn, your computer is going to forward the request to port 8080 where your application is listening, and our application responds to the request by returning a white label error page. Let's fix it. The next step when we make a request on localhost 8080 is for the HTTP server to send back a static web page. The static folder is where you should put static web contents. Resources, static. So examples of things that you would put in the static folder are images, logos, CSS designs, and static HTML. In order to send the client a static web page, add an index.html file to the static folder. Index.html. Now, whenever you want to write any HTML code, you have to start with a boilerplate template. And as a Spring Boot developer, I don't expect you to know any HTML. So what we'll do is go to the marketplace and look for the HTML boilerplate extension. Let's try HTML5. There you go. Click install. All right, we may have to relaunch VS Code for this to work, but it's worth a try. I'm going to write HTML boilerplates, and it works. Now you can go ahead and delete all of this, delete all of that, and we're good to go. All I want you to know is that metadata goes here, and your visual elements go here. We're not too concerned with metadata at the moment. Is a header, h1, that says Hello Spring. So what h1 is going to do is it's going to populate your web page with a big header that reads whatever string you provide. And one thing I want to stress is that it's really important that you name your file index.html. When Spring Boot is responding to an incoming request, by default it looks for the index.html file. So now what we can do is rerun Maven Spring Boot run. Make that same request, and the HTTP server responds with a big header that says Hello Spring. The client sends a request to port 8080. The Spring Boot application's HTTP server listening on that port receives the request. Spring Boot looks for the index.html file and responds with it. The HTML file populates the browser with Hello Spring. Now you can change the port that Tomcat runs on. You can choose the port where your app should listen for requests. And recall that application.properties is the file where you can configure the settings of your application. So here what we're going to do is we're going to say server.port is equal to 9090 to change the default port. So now we're going to rerun our application. And now try sending a request to port 8080. There is nothing listening on that port. That's because the application's HTTP server is listening on port 9090, so you must send the request there. All right, to recap, you launched an HTTP server using Spring Boot. First, you added the Spring Web dependency. The Spring Web dependency starts up an embedded HTTP server called Tomcat, and by default, the HTTP server listens for requests on port 8080. Inside the application.properties file, you configured the web server to listen on port 9090. Your browser and HTTP server live inside of the same machine, so your full address is localhost 9090, such that localhost loops a browser's request to your machine, and then your machine, upon receiving the request, forwards it to port 9090, where your Spring Boot's HTTP server happens to be listening. Spring Boot looks for the index.html file and responds with it. The HTML we sent back populates the browser with a big header that says Hello Spring. Let's talk about Maven Dependencies. By putting a few lines of XML inside of the pom.xml file, Spring Boot seems to just magically fetch all of the files that it needs to bootstrap a web application. But one should wonder, where is it actually grabbing these files from? In this lesson, you will learn the difference between the central Maven repo versus the local Maven repo. A dependency refers to a packaged library of files, i.e. jar files, that your application can use. Now, the central Maven repository is where Maven downloads your dependencies from. The local Maven repository is inside of your computer. Once the dependencies have been downloaded, Maven puts all of them into your local repository. So, putting it all together, when you run your application, Maven looks for the dependencies that it needs inside your local repo. If it finds them, it's going to use them in your project. Otherwise, it will download the dependencies from the central Maven repo and then store them in the local Maven repository. From there, your application can use them. So if we actually go back and run your Spring Boot application, notice that it doesn't really download anything. We don't see any logs that say, oh, downloading this dependency from the central Maven repo. That's because it already downloaded all the dependencies from the previous run. If you're using a Mac, go to your desktop and then press Command-Shift-G. And from here, you can actually navigate to your local Maven repo by going to .m2 for Maven /repository. If you're using Windows, you go to the C drive, users, whatever your username is, then go to the Maven, the M2 repository. And inside of your local repository is where you'll find all of the dependencies that were downloaded from the central Maven repo. Also, a quick glance will show you that there are many packaging types. There's jar, war, pom, rar, zip, but it's not a Maven course, so we don't really care. The take-home message is a Maven dependency consists of a packaged library of files that your application can leverage. You can go ahead and delete all of them. Now, if you go back and rerun your Spring Boot application, now it re-downloads all of the Maven dependencies that it needs from the central Maven repo. You can see it says downloading from central, and then it's going to store these dependencies inside of your local repo, as it's doing right now live. And then from there, our application is going to use these dependencies to accomplish whatever that it needs to do. The latest dependency that we added was Spring Boot Web, and our application was able to effectively leverage the files provided from the Spring Web dependency to kickstart an HTTP server on port 9090. So to recap, a dependency refers to a packaged library of files that your application depends on. When your program needs a dependency, Maven first looks for it in the local repository. If found, it will use them. Otherwise, it will download all of the dependencies files from the central Maven repository and store them in your local repository. And from there, your application can use the dependency to accomplish whatever it is that it needs to do. The Spring Boot DevTools dependency accelerates development time. I like to use the Maven clean command at least once to start from a fresh build, and then I rely on the Spring Boot DevTools dependency to auto-restart the application every time I make a new change. So in this lesson, we will add the Spring Boot DevTools dependency. Spring Boot DevTools instruments your application to pick up new changes and restart. So what we're going to do is Google Spring Boot DevTools, and we will go to the, you know what, let's be more specific, we'll say Central Maven repo. Go to the Central Maven repository. I will choose version 2.6.7 in accordance with my Spring Boot project. Click that. And I will synchronize the build file. And now here, I can add the dependency. Now I can actually remove the version number. That being said, the version for Spring Boot starters will be 2.6.7 by default. And what this dependency will do is provide all of the files needed to instrument your application to always restart when you make a new change. So let's try it out. I'll start off with a clean build, Maven clean Spring Boot run. All right, this time I actually have my Tomcat server running on port 8080. So I'll go ahead and make a request there, localhost 8080, hello Spring, all right. And now if you focus on my terminal, if I ever make a change in the back end, for now I'll just add a print statement. Notice that it auto restarts. That's pretty cool. But we don't need to make any changes in the backend right now. We'll go right into the view and I'll add another header that says, how are you? And now I don't have to restart the application because when we make a request on localhost 8080, it's going to return the updated view. Beautiful. There's just one thing I want to warn you about is if you find VS Code ever getting slow for you, or you feel like auto importing or the autocomplete feature just randomly stopped, then shut down DevTools using Control-C. It's usually the culprit, but most of the time it works really well. So to recap, you added the DevTools dependency that picks up new changes and restarts your application. Every now and then, I like to start off with a fresh build using Maven clean Spring Boot to run, and then I let DevTools take care of the rest. In this section, you will build an application that lets the user submit a grade. I will submit a grade for Harry. We'll give him a C- in potions. And you can also update an existing grade, so we can upgrade that C- to a B-. All right, and you will write all of your code around the model view controller design, where model stores the data, view represents the visual elements of a web page, and controller ties everything together. Throughout this section, and for the remainder of this course, I'm going to be using VS Code, but not to worry. If there's anything in VS Code that would need to be done differently in IntelliJ, then there's going to be two separate lessons, one for Path A and one for Path B. In this video, you will launch the starter project. I'm assuming you downloaded the course resources, and if not, please go back to the workbooks and challenges video. In any case, follow this path in your course resources and launch the Grade Submission app inside the Starter folder. Alright, once you launch it, go to the pom.xml file, and here you'll notice that I added the DevTools dependency. DevTools was covered in your first challenge because it instruments your app to auto-restart every time you make changes. At first, I'm always going to use Maven clean Spring Boot to run to clean the target folder and start fresh, and then I'll be using DevTools to accelerate the process. Alright, you'll notice that I also added the Thymeleaf dependency. Don't worry too much about it for now. All I can say is we need Thymeleaf in order to work with HTML templates. A template is dynamic HTML whose UI changes based on the data that you provide, but we'll get to that later. That's all for now. This is the starter project that we're going to start coding on. MVC is a design that lets you build flexible applications that scale. Spring Boot web applications follow the model view controller design. So in this lesson, you will understand the model view controller design. The view is what the user sees. When a user makes a request, the server sends back HTML. That HTML populates the user's web page. This is the view. The model is data needed by the view. The view is a skeleton. The view needs data to become meaningful, and the data that populates the grades table in this case is the model. The controller essentially glues the model and view together. It manages the model and presents the view. The model represents the data. The view represents the visual elements of a web page, and the controller allows them to interact. It takes the data and it sends it to the view. So to paint a full picture, the controller handles every web request. When a user makes a request, the controller maps the request to a handler method. The handler method, in this case called getGrades, fetches data. It stores the data inside the model. The view is a template that represents the visual element of a web page. Alone, the view is meaningless, so the controller sends the model to the view. The model populates the view with meaningful data. And finally, the handler method returns the updated view. So to recap, Spring Boot applications follow the model view controller design. The view is what the user sees. The model is data needed by the view, and the controller responds to requests by managing the model and presenting the view. The controller makes up one component of the MVC architecture. The controller responds to web requests by managing the model and presenting the view. In this lesson, you will create a controller inside Spring Boot. Spring Boot uses annotations to create magic. Annotations create the sensation of magic. They add logic to an application without you having to add any code. So in the model view controller section, you will encounter these four annotations: controller, get mapping, post mapping, and request param. Each annotation magically adds functionality to your Spring Boot app. This annotation converts a class into a controller, as the name suggests. So when you annotate a class with @controller, it becomes the entry point for all web requests. In turn, the controller class contains handler methods. A handler method can respond to a web request. Alright, first thing we're going to do is inside the grade submission folder, create a new file called grade controller.java. And what we're going to do is annotate the class with @controller. If you don't annotate the class with controller, Spring Boot will not see this class and nothing inside is going to run. Now recall, the controller is the entry point for all web requests, and one type of request that it can handle is GET requests. A GET request is when the user is requesting a resource. In other words, a GET request is when the user wants to get a resource from our Spring Boot app. The user can make a GET request from the browser. The URL that they type must specify the host, the port, and the path. So in the last section, you were actually making GET requests the entire time. The host and port will send the request to the Spring Boot app. Once the request reaches the app, the controller is its entry point. The controller uses the path portion of a request to decide which handler method to run. The handler method responds by returning a resource. In this case, it's some type of HTML. Alright, the next annotation is getMapping. This annotation magically converts a method into a handler method. The handler method can respond to GET requests. When you annotate a method with getMapping, it can respond to a GET request. The getMapping annotation receives one argument, a path. This method can respond to GET requests made on the path hello. So inside gradeController.java, create a method called sayHello that returns a string, public string sayHello. And the string it's going to return is HTML view for the time being. And now we'll give the method the getMapping annotation. Wait for autocomplete to show getMapping. Click on it. And you can see that it auto imports. And now we want to make sure that this method responds to GET requests made on the path hello. Okay. You can go ahead and run your Spring Boot application. And then from your browser, make a request to localhost 8080/hello. And we get an error code. The user makes a request on the path /hello. The controller maps the request to a handler method that matches the path. The handler method tries responding with a view called someHTMLView. What it does is it actually looks inside the templates folder. It can't find anything, so it returns an error code. The controller is the entry point for all web requests. Once the request reaches the app, the controller is its entry point. The controller uses the path portion of a request to decide which handler method to run. The handler method is the one that responds to the GET request. The view makes up another component of the MVC design. The view represents the visual elements that make up a web page. So in this lesson, your handler method is going to return a view. When a user types in a URL into the browser, they're making a GET request. They are requesting a resource. The controller inside Spring Boot intercepts the GET request, and then it maps the GET request to a handler method, and the handler method responds with a view. Alright, the view is what the user sees. The HTML that a handler method returns makes up the view. What I'm going to do is rename this method to getGrades. And I will change the mapping URL to /grades. This handler method, when invoked, is going to respond with the grades HTML. Okay, you can go ahead and run your Spring Boot app. I guess I'll just have to rewrite it. Maven, clean, Spring Boot run. And now from your browser, make a request to localhost 8080/grades. Beautiful. The user makes a request on the path /grades. The controller maps the request to a handler method that matches the path. The handler method tries responding with a view called grades. It finds the view inside the templates folder and returns it. The view only contains the visual elements of a web page. The view needs data to become meaningful, and the data that populates the view is called the model. That will be the focus of the next lesson. So to recap, the view is what the user sees. The user makes a request on the path /grades. The controller maps the request to a handler method that matches the path. The handler method tries responding with a resource called grades. It finds the view inside the templates folder and returns it. As Java developers, we only care about the back-end logic. We don't really care about the front end. The front end is an interface of buttons, text, and images, all written in HTML and CSS. The HTML is something that will already be given to you by a front-end developer. Your job is to simply manage how it's presented. The model makes up another component of the model view controller design. The model is data that the controller sends to the view. Without a model, the view is meaningless. The view alone offers visual elements, but nothing more. In this lesson, you will learn about the model component. Let's go through the whole process. First, the user makes a GET request. The controller maps the GET request to a handler method. Step 1 is, courtesy of Spring Boot magic, a handler method has direct access to the model. The handler method has access to the model directly from its function parameters. The handler method can create data in the form of plain old Java objects. Imagine there's a grade class. From it, the handler method can create 3 plain old grade objects. Step 3 is to store the data in a model attribute. The handler method can add an attribute to the model. The model attribute consists of a key that maps to a chunk of data. At a high level, this diagram shows how the handler method can add data to the model. Once the data is added, the controller sends the model containing all of that data to the view. Before we get ahead of ourselves, we can start with step 1. Think of a model as a container that holds data. Every handler method has access to the model. Courtesy of Spring Boot magic, handler methods have direct access to the model. You can access it directly from the method's list of parameters. Model, make sure to import it. A Pojo class is the simplest type of Java class. A Pojo class contains private fields, constructors, as well as public getters and setters for each field. From a Pojo class, you can create a plain old Java object. A Pojo represents a piece of data. Looking back at the grades page, each row inside the table needs a piece of data that contains the student name, the subject, and the score. In any case, because each piece of data needs 3 fields, what I'm going to do is add a Pojo class with 3 fields. So I'll create a new Java file called grade.java. And I will create 3 fields: private, string name, private, string subject, private, string score. Okay, now what I want you to do is go to the extensions and download the Java Code Generators extension. I'll give you a couple of seconds to do that. Okay, and now what I can do is go to Java Code Generators and generate a constructor using all fields. I will generate an empty constructor as well. Generate all of the getters and setters. And that should be it. From this Pojo class, you can create data in the form of grade objects. So inside the handler method, what I'm going to do is create a new object of the grade class. And the parameters will be Harry. The subject is potions. And their score will be a C-. The grade object is a piece of data. Referring back to the diagram, the handler method creates data and stores it in the model. Then it sends the model containing all of that data to the view. So back to the code, you need to somehow add this piece of data to the model. An attribute maps to a piece of data. You can add a model attribute using the method addAttribute. It accepts 2 arguments: the name of the attribute and the data that it stores. Inside of your handler method, add an attribute to the model called grade, model.addAttribute, grade, and the grade attribute will map to the grade object. And that's it. Now your model contains data. The next step is to merge that data with the view. In this lesson, you added data to the model. Thymeleaf allows you to combine the view and the model. Your model contains data, but the next step is to merge that data with the view, and that's what Thymeleaf is for. So in this lesson, you will use Thymeleaf to combine the view and the model. Let's go through the process. Right now, your view is just static HTML, and your model contains an attribute that maps to a grade object, a key value pair, if you will. Somehow, Thymeleaf is going to magically merge the data from the model with visual elements in the view. But how will it do that? The answer lies in variable expressions. A variable expression executes on a model attribute in some way. Repeating it one more time, a variable expression executes on a model attribute. A variable expression consists of a $, followed by curly brackets. Inside the curly brackets, the variable expression executes on a model attribute in some way. In this case, the variable expression returns the model attribute age. There are many ways that a variable expression can execute on a model attribute. A variable expression can be used to return a model attribute or a value that derives from it. It can execute a condition based on a model attribute. A variable expression can also be used in a loop. And it can also execute utility methods on a model attribute. In this lesson, we're going to be looking at the first scenario. Thymeleaf text displays a text value. This variable expression returns the score that derives from the model attribute grade. Now, this value could be a string, could be a boolean, could be a number. Thymeleaf text doesn't care. All Thymeleaf text is going to do is display the result as a text value. You should already have Thymeleaf installed as a dependency. The Thymeleaf dependency is required to work with HTML templates. So far, your table only contains one row with a bunch of headers, as is reflected in the UI. Per the HTML cheat sheet, I'm going to add another row that contains 3 data cells. So these are header cells. We're going to create data cells. I'll copy this 2 more times. The first cell, we're going to say Harry. The subject will be potions. And the score is a C-. Alright, now thanks to Spring Boot DevTools, our application should reflect the changes, and it does. And now your table has another row of data. However, the data was written directly into the HTML. So remove the hard-coded data, but keep the cells as is. And so inside the first cell, we're going to set Thymeleaf equal to a variable expression, and Thymeleaf text is just going to display whatever the result is as a text. In this case, we just want our variable expression to return the name field that derives from the model attribute grade. We're going to copy this over here. Here we can display the subject. And here we will display the score. This is really important. The variable expression invokes the getter of each field, so the naming needs to match. So if I go back, thanks to Spring Boot DevTools, everything should rerun. And voila, Thymeleaf uses the model to populate the view with data. Now before I wrap up this lesson, let's just assume we did happen to misspell one of the fields. What would happen is we would get a big error. Now what's really important with these errors is to not get intimidated by them, because somewhere in all of these logs there is a very useful message that's going to tell you exactly where you went wrong. So here it tells us an error happened during template parsing. Okay, what is that error? Let's scroll through, and eventually you'll see that the parse exception occurred because it could not find the subject field that it was trying to get from the model object. The model object has a grade.subject field, so make sure to fix it accordingly. All right. And so to recap, you use Thymeleaf to populate the view with data from the model. When a user makes a request, the controller maps the request to a handler method. The handler method stores a grade object inside the model. Each cell in the table row displays a field value from the model object. After merging the model variable, the controller presents your updated view. In this lesson, we're going to finalize the back end. As Spring Boot developers, we don't necessarily care about the front end. The front end represents the view, the UI elements that the user directly sees and interacts with. You can think of the front end as a bunch of mindless UI templates that rely on the back end to give it meaningful data so that these templates can be filled and therefore make sense to the end user. All right, so it's the back end that contains all of the business logic and meaningful behavior that is needed to generate this data, which is sent back over to the view, wires everything up in a way that makes sense to the end user. All right? Now, typically in a real world scenario, the front end is programmed using something like React and Angular and hosted in a web server that's separate from your Spring Boot backend. But in this case, we're using Thymeleaf. Thymeleaf is unique within the Java ecosystem, in this case because it directly integrates with our Spring Boot backend, allowing our Thymeleaf frontend and Spring Boot backend to run under the same application in a single web server. This isn't very practical in a real-world scenario because you never want your front end and back end to be too tightly coupled, but it's perfect for a learning environment because it allows us to start running things and seeing results very quickly, and therefore accelerating the process in us learning the Spring Boot fundamentals. But in an upcoming section, I'm going to show you a more realistic full stack development scenario where you've got the front end running on one web server and how to hook it up to our Spring Boot backend so that it's receiving data from it and rendering meaningful views to the end user. Okay, but for now, we're going to stick with Thymeleaf because we still have a lot of Spring Boot fundamentals to learn. So what I want you to do is start by loading the Spring Boot project by following this path inside of your Bootcamp resources. The Spring Boot Starter project should be under the folder Checkpoint, so make sure that you load that, and I will see you in a couple seconds. All right, let's rock and roll. We're going to start by reviewing the contents of our starter project. So here we have a grade class, obviously from which grade objects can be created. Okay, and whenever a grade object is created using this parameter list constructor, it's automatically given a unique identifier, and it follows that the subject, score, and name will start off as null, which makes sense. We also have a constants class, which for now just contains a simple constant that equals a random integer. That integer can be whatever you want. I just chose -1000. And we also have a grade controller. Now, this isn't too far from what we initially had before. The grade controller instruments the web server to listen to GET requests made on the path /grades. And whenever a request is made there, what it's going to do is grab all of this grade data and use it to fill the grades UI template. And then once the grades Thymeleaf template has been filled with this data, it essentially renders the front end. Okay, so here we have a very clear interaction between the Thymeleaf front end and our Spring Boot back end. Because we're using Thymeleaf, they can directly talk to each other under the same web server. But usually what would happen is our Spring Boot backend would take this data, serialize it into a notation called JSON. We'll talk about that in upcoming sections. Send that JSON data to the web server that is hosting our separated front end, and then the front end, which is coded using something like React or Angular, would know how to process that data accordingly. But right now we've got Thymeleaf, which is beautiful because it helps us get up and running very quickly and learn the Spring Boot fundamentals, okay? So here, Again, reinforcing the notion of a backend and a front end, a front-end developer has already created all of these UI templates ready for us to use. So as backend developers, we never really need to touch front-end code. It's already given to us. And our job is, based on whatever the front end looks like, we need to wire up the back-end logic accordingly. So here you'll notice that we have a form HTML. And the front-end developer was kind enough to leave us comments telling us what kind of data this Thymeleaf template expects from our backend. And before we look at any of these comments to understand what kind of data we need to send from our Spring Boot backend, let's just start by rendering this form. All right, so back to the grade controller, we're going to instrument the web server to also render the form upon a GET request being made on the path / on the home page in this case. I'm going to call the handler method getForm. All right, this parameter stays. And what I'm going to do is add a request parameter. I'll explain what that is in just a second, but the import should already be there for you. Request parameter, required false. I'll explain what that is in just a second, just bear with me. String ID. So what this basically says is it means the URL may or may not have an ID parameter. For instance, if the user decides to make a request to, well, in this case, localhost 8080, just like this, that would work. If they decide to also include an ID parameter like 1234, that ID is going to be received by the following parameter and can be manipulated here accordingly. So we're giving the end user the option to provide an ID as part of their GET request. Now, why would this be useful? Well, this form, all right, whenever it submits a grade for a student, we want it to either update an existing grade or submit a new grade. The logic, the behavior, the business logic for whether or not a grade is new or already exists can be determined here in the back end. Okay, so what we want to do here is define an index. And that index is going to be based on whatever this very special function that I coded up returns, getGradeIndex. And what this does is it receives the ID from the GET request, and it uses that ID to search through all of our existing grades. If it finds a match, it's going to return an index. If it doesn't find a match, it's going to return -1,000, some random number. Okay, I made sure that this number was negative so that it doesn't conflict with any potential indices that represent a particular grade. All right, and now what I can do is define a grade object. Okay, so in the event that the index equals constants dot not found, in that case, then we're simply just going to create a brand new grade. All right. And that brand new grade, which we're creating based on this parameterless constructor, is automatically going to be given a unique ID. All right. And here we can use the ternary operator such that if this is actually false and getGradeIndex did indeed return an index, then what we can do is say studentgrades.get the grade at a particular index. All right. Sorry, not index. And now what do we put for model.addAttribute? Now I want to reemphasize that because we're using Thymeleaf in this case, we need to kind of understand how it integrates with our backend, but usually had our front end been coded with something like React, then at this point, we would have been good to just serialize this grade into JSON and then send it over to the web server where the front end is running. But because the Spring Boot backend and the Thymeleaf front end in this case are tightly coupled, we need to understand the fact that this form is bound to whatever object is given to it by the model. Okay, so here we need to say model dot add attribute. The attribute name in this case needs to be consistent with whatever our Thymeleaf template is expecting, grade, and then we're going to give it the following grade object, whether that's a new grade that we're creating now, or whether that's an existing grade that we need to give to the form. All right, and that's pretty much it. Now we're ready to run our application. So I'm just going to run my app using Maven, not using the Maven wrapper. You can do whatever you want at this point. Maven clean, Spring Boot run. Oh, my apologies, guys. I loaded up the checkpoint folder, which doesn't really have a pom.xml file. What I need to do is load the grade submission, or I could just cd into it. What am I doing? All right, now our terminal is pointing to grade submission. Now I'm going to say Maven clean, Spring Boot run. All right. I'm going to say localhost. Why isn't it allowing me to type? Come on. 8080. And we see grades because I'm a knucklehead. I didn't return the form. Sorry, guys. And here we see the form page that was provided by our form.html, and no errors should appear in the console. And because we made a request on an empty path, we didn't give an ID, so it probably ended up creating a new grade object binding this empty grade to our Thymeleaf form. All right, so each name, score, and subject field is bound to the fields of this grade object. And if you look inside the form, here they tell us that the ID is hidden, but still crucial for identifying whether this is a new grade or an existing one. All right, so what I want to do now is actually run this application in debug mode so that I can use breakpoints. IntelliJ users, you may feel free to debug the way that you're supposed to. In VS Code, I can just press the debug button. All right, and upon making a request on the empty path slash, the handler method intercepts this request. Here the ID is null because we didn't pass in an ID, so I can just skip over that. Obviously, a new grade is going to be created as a result. That new grade is going to automatically be given a unique identifier. Name, subject, and score will be null. We add this attribute, this grade object, such that it binds to our form itself. Here in the Thymeleaf template, the form itself is bound to whatever object we pass into it, such that the name input field is bound to the name field of that object. The score input field is bound to the score field of this object, etc. And the form also has an ID input. It's just that it's hidden, but it's important that we have this ID input so that we can reference the ID of that specific grade that we're about to submit, that we're about to update. Okay? And now upon us pressing submit, nothing really happens because the submission, upon the submit action, what it does is it redirects the end user to another path handle submit. But we don't really have any handler methods that can intercept any requests made there. So we're going to do that right now. But before we do that, what I want to do is try to make a request passing in an ID parameter that equals 1, 2, 3, 4. We have our breakpoints again. Here, the same thing happens, but it expects an ID of 1, 2, 3, 4. It tries to find a grade that has this ID. Obviously, it won't be able to. So again, it creates a new grade, and that new grade object is what ultimately is going to be bound to the various input fields of our form. So once we render the form, everything should work out. Come on. Oh, let me just press this play button. Cool. All right, enough about that. So now when someone presses submit and it goes to handle submit, we need logic for that. Actually, before that, what would happen if I made this to true? Let me not clean the target folder. Let me just do a quick Maven Spring Boot run for now so that it runs quickly. All right. In this case, if I make this required to true and don't pass in an ID, we get the following error. Okay, cool. Let me put this back to false because we don't always expect the user to pass in an ID. All right, only when they want to perform an update. And now, whenever there's a form submission by the front end or by the client, what they're intending to do is make changes to our data store. Whenever we're retrieving stuff from the back end, that can be deemed a GET request. Whenever we're making changes to the data from the back end, that can be deemed a POST request. Okay, so in order to accommodate this POST request, we need a POST mapping handler method. So here I'm going to say POST mapping. All right, allow this to autocomplete. Make sure that you get this import. And the POST mapping, this handler method is going to intercept requests on the path / handle submit. You can call this whatever you want. I think submit form makes the most sense. And what the submit form handler method is going to receive from our post request is a grade object. Why? Well, our Thymeleaf form is bound to whatever grade object it was initially given, and when the teacher or whomever inputted a name, a score, as well as a subject, those are going to get bound to the fields of that particular object. The ID that was initially passed in won't change, so now our grade has been fully updated with data, and our form is submitting this updated grade so that in the back end, we can take this grade and populate our student grades array list. All right. And so initially, what I want to do is ensure that whatever grade was given to us by the form, I want to verify its ID against any of the grades that already exist in the data store, okay? Because that will let me know whether I want to update the grade in our data store or add a new grade. So int index is equal to the handy get grade index function, grade.getID. All right, and now here I'm going to say if index is equal to constants not found, then what we're going to do is add a new grade. Add new grade. Student grades dot add grade. Now here we're using an array list, but in the future, I'll show you how to perform all of these actions using like something more durable like an SQL database. Else, student, we want to update a grade. So let me just add a comment, update existing grade. Student grades dot set the grade at the index. Now, after we've updated the grade. After we've updated our data store, the next thing we want to do is redirect the client to the grades template. How do you perform a redirection? You want to write redirect followed by a colon / the grades template. All right. Now this we don't really need to touch, because whenever a request is made on /grades, whether that's through a redirection or whether they just made the request as is, all it's going to do is look at the data store, look at all the grades, bind it to the table of grades, and then display all the data. So here the grades HTML that was very kindly provided to us by the front-end developer was like, hey, I'm going to create the UI. It's a table. All you need to do is give that table a list named grades. And the table will go through all the hard work of iterating through all the grades in this list and displaying them accordingly. And that's it. All right, so we can go back over here. All right, and I'm pretty sure we're done. Localhost 80. I'm gonna give Harry a grade, a score of A+. In potions, submit it. Beautiful. Now this update button is interesting, all right? Because the front-end developer, what they did is they configured this update button to make a request back on the home page, passing in an ID parameter for whatever grade you pressed update on. Okay, so essentially our controller is going to receive an ID, look for the grade that we want to update, pass it into our form, and then we're essentially updating a grade as opposed to creating a new one. So if I update Harry's grade to be a C+, it gets updated instead of a new grade being added. And so here if I go back and give Hermione, let's say, a score of A+ in arithmancy, now we get a new grade because this grade object had a completely different ID. All right, now I don't want you to get too bogged down in the semantics and how these Thymeleaf forms are instrumented, because ultimately it doesn't matter. The front-end developer already programmed all the UI elements, and they told us, look, for the form, just give me a grade object and I'll take care of the rest. For the grades HTML, they told us, hey, just give me a grades array list and I'll take care of the rest, which is essentially what we did. We went back into the back end, wired everything up, and it all worked seamlessly. Now, I like to end every single lesson with a breakpoint session just to make sure that we fully understand the flow of how everything is happening. So what I'll do is I'll stop this runtime and I'm going to add breakpoints here, 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 maybe one here as well. What the heck? And I'm going to run the app once more in debug mode. I don't get an error. All right, first I start by making a request on the empty path. And obviously there's no ID. This is going to be null. So a new grade is going to be created, and that grade is going to be automatically given a unique identifier. Remember this identifier, 9CB93, whatever. All right, and that specific grade is going to be bound to the form inside of our form.html, such that the input type, which is hidden, is going to be bound to that object's ID, and the name, score, and subject are going to be bound. Those inputs will be bound to the empty name, score, and subject fields. All right, such that when I do submit the form, input Harry, a C+, for the subject potions, those inputs are going to be bound to the object fields such that when I press submit, a request is going to be made on the path/handle submit. The object, the grade object that was bound to this form is passed into submit form. Notice how it preserved that grade's ID, 9CB, whatever, and the name, score, and subject, which are bound to each input, were populated with the respective values. Here we check if the index is not found. In this case, it is. It's a new grade, so the grade gets added to our student grades array list. This now has one grade. And so now, upon redirecting to our grade, let's just press continue. It's going to display that table of grades. Beautiful. And now what happens if I press update? The update button, as you can see here, is going to make a GET request on the path / passing in that same grades as ID. All right. Remember the grade with the ID 9CB. In this case, it's going to detect that that grade already exists. It's going to find out that the index of that grade is 0. So it grabs that existing grade and binds this grade to the form inside of our form.html. All right. And because that grade already has populated fields, the input fields of the form, which are bound to each field in the grade object, already have pre-populated values. And here you can choose which ones you want to update. So now we want to give Harry a D+. All right. Because the grade already exists, the else clause is what's going to get triggered, and the grade instead of student grades is going to be updated at that index. And then we redirect that request towards /grades. This handler method receives the request, and it renders the updated grades list as a table. All right. And now, not something you really need to know, but this has two buttons, form and grades. The form button goes back to the empty path. Grades goes to grades. So if I go back to form, the path here, it doesn't pass in an ID. So this allows the handler method to create a new grade object. This new grade object is going to be bound to our form, allowing us to submit a grade for a new student. Okay? So this form is bound to an entirely new grade object with an entirely new ID, which is hidden to us. And this new grade object, we're going to give to Hermione, give her an A+ in potions, submit that. So notice that this new grade object has an entirely new ID by virtue of creating this new grade with the parameter list constructor. Obviously, this grade is not going to be found because it's totally new. Its ID will not match anything in the grades array list. It's going to get added. Redirect is going to redirect us to the grades page, which renders the contents of our grades array list. All right. And so that's really it. The only thing I want you to take away from this is we were provided the front end. We were provided the HTML templates, and all we had to do was wire everything up by coding up the business logic inside of the back end, code up the meaningful behavior that is smart enough to generate the data that needs to be sent back to the mindless front-end UI in order to render a view that makes sense to the end user. So that's going to be the theme throughout this course. We're given a front end, and we just need to modify the back end. And eventually we're going to abandon Thymeleaf and simply focus on the back-end logic itself and send over serialized JSON data. But that's something we're going to cover in upcoming sections. I'll see you there. Welcome to the field validation section. In this section, we're going to prevent the user from submitting meaningless data. For example, if they leave the name blank, if they put an invalid score of, let's say, R+, and if they don't submit a subject, we're going to display error messages. I hope you're excited. I will see you inside. Field validation prevents the user from inputting invalid data. Data storage costs money, and your app should only store what's meaningful. So in this lesson, you will add constraints to the name and subject fields. Let's go through the field validation process. It takes 5 steps. Step 1 is to annotate the fields that you want to validate. In this example, courtesy of Spring Boot Magic, the min annotation can check if the age provided is at least 18 years old. Step 2 is to pass in a bad input. When the user presses submit, a post request will be initiated, and the post request payload will have as many parameters as there are fields attached to each input. The handler method validates the fields. Spring Boot will create an empty person object that's ready to receive the payload from the post request, and Spring Boot is smart enough to use your setters to update every single field in this object with payload from the post request. As we update the object, Spring Boot is going to try and validate each field. The first field is valid. However, we require the age to be at least 18, so the age field is not valid. A binding result will carry the result of the validation. So in this case, our validation process does have errors. In step 5, if the result is negative, the handler method forces the user to stay in the form view. So the binding result has errors, which means we're going to force the user to go back to the form. In step 6, Thymeleaf catches the errors and displays them to the user. So the binding result keeps a record of the object name where the validation process took place, and this object name is going to match whatever object Thymeleaf attached to our form. It's going to keep a record of all the errors associated with each field. There is an error associated with the age field. Thymeleaf can access that error from the binding result and display it in the form. So step 1 is to actually annotate your field that needs validation. And field validation in Spring Boot is like magic. Spring Boot provides many standard annotations that you can apply to your fields. This will be inside of your cheat sheet, so not to worry. Now each annotation validates a field in some way. In order to leverage these annotations, we're going to have to add the Spring Boot Starter validation dependency. So I'll go over to Google and I will Google the Spring Boot validation dependency. We can grab it from the central Maven repo. I'll grab the one that corresponds to my application version 2.6.7, but that won't really matter because what I'm going to do is delete the version number because the version for Spring Boot starters has already been specified on top, and I will choose to synchronize the build file. All right. This dependency provides all of the classes we need for field validation. So first, what I'm going to do is go to grade.java and apply the not blank annotation to name and to subject. We'll say, and just as a side note, if this doesn't auto import for you or it doesn't show you the option, try just running the app first. And if that doesn't work, relaunch your editor. This applies to both VS Code and IntelliJ. And in IntelliJ, you should have this invalidate cache button. Make sure to press that and your problem should be solved. So I'll add the not blank annotation. over here and here as well. And each constraint can return a message if the user violates it. This should come with a default message that we're just going to override. We'll say name cannot be blank, not blank, blank. And we'll do the same thing here. We'll just say subject cannot be blank. Now, careful to use not blank instead of not empty. The not empty annotation doesn't consider the fact that the user may enter a lot of white space, which isn't considered empty, but is considered blank. All right, step 2 is to pass in bad input. The post request carries the data to your app, and regardless of the input, it's going to populate the object with fields. You can actually verify this by running your app, and I'll just go ahead and print the grade.subject, or getSubject, I should say, and grade.name. So even if we have those annotations, it's still going to update the fields in this object. Let's test it out. We'll leave this blank, and we'll say C-. And you can't really see anything because the values are blank, but the field values were printed. They're just white space. So take home message, regardless of the input, Spring populates every field in this object. So step 3 is to apply the valid annotation. The valid annotation checks if the fields are valid. So as Spring is populating the object with field values from the post request, valid can actually check if any of them are invalid. So make sure to add this annotation, otherwise the validation process will not happen. Now step 4 is to check for the binding result. Binding result carries the result of the validation. After valid checks if the fields are valid, binding result carries the result of the validation. You can access the binding result from the handler's list of parameters. Binding result, result. Now this binding result must always come after the object that is being validated, or else Spring is going to fail to validate the object and it's going to throw an exception. So do not mix the order of the parameters. The object's fields get validated first, and the binding result comes right after. And so after Spring Boot validates the object, we're going to check if the result has errors. So we'll just print has errors with a question mark, and we're going to print the Boolean value that results from result.hasErrors. Okay, now I'll go back to just use the button. I'll submit a form where the field values are blank, press submit. We do have errors, cool. Now step 5 is to return the appropriate view. A negative binding result must force the user to stay inside the form. If there are errors, the handler method should return the form view. So at the moment, regardless of errors, the handler method is updating the data store and redirecting them to the grades view. That's not how it should be. If there are errors, we don't want to redirect the user anywhere. We want to keep them inside the form view. So we'll say if result.hasErrors, then we're just going to return the form. The binding result has errors, and so the user stays inside the form. Now, step 6 is to actually display the errors to the user. This binding result that you see here, it keeps a record of the object as well as the fields that were violated. This information, upon keeping the user inside the form view, is sent back to the Thymeleaf template. All right. If I go back here, Wonderful. The first paragraph element displays the constraint violation for the field name, and the second paragraph element displays the constraint violation for the field subject. Now, some of you might be wondering, why not redirect the user to the home page? There are two issues with this. Number one, why would you redirect them to a page that they're already in? Number two, if you do this, you would actually lose the binding result data because now you're making an entirely new GET request. So all data that was initiated from the post request would now be gone. Try it out. And we see nothing because it made an entirely new GET request and we lost all the data from the binding result. So the solution is to just return the Thymeleaf template. And right before returning it, Spring Boot is going to send over all of the necessary data. Only redirect the user if the form submission is successful. That's when it would make sense. Otherwise, if the result has errors, we don't want to redirect them anywhere. We just want to keep them inside the form. It's always good to trace the runtime to figure out exactly what's happening inside of your application. So what I'm going to do is just apply breakpoints inside of submit form, nothing else. And you know what? Maybe I'll apply some breakpoints inside the setters. We'll put some in, oh, not the getters, the setters. We'll put some in set name, set subject, and set score. All right, I will terminate the application and rerun it in debug mode. All right, it should have ran by now. I'll start by going to localhost 8080. And I will submit a blank name, a score of C-, as well as a blank subject. And upon pressing submit, it should initiate a post request and carry all that data to our backend. Indeed it does. And I forgot to put a breakpoint here, but essentially, as we saw a million times before, submit form intercepts the post request. It starts by creating an empty grade object, and Spring Boot is smart enough to populate every single field inside this empty grade object with a parameter from the post request. Starts by updating the name with a blank value, updates the score with a blank value, and it updates, actually no, the score was not blank, we did put a C-, but the subject was blank. And after updating every single field inside of the grade object with a value from the post request, it gets validated and the binding result carries the result of this validation. So if we drill into result, you can see that it has an array list of all of the errors involved in this validation. There is one error that says the name cannot be blank, and there's another error that says the subject cannot be blank. So if I press next, nice. Now let's just say everything runs successfully. So we'll say Harry, we'll say potions, press submit, updates the name, score, updates the subject with payload from the post request. The object is fine. You can see that the result does not have any errors. The size of the errors array list is 0. So this if block is going to get skipped. It's going to successfully submit this grade object to the array list. Then it's going to redirect the user to make a GET request on /grades. That's exactly what's going to happen. I didn't put a breakpoint here, but it will return the grades template populated with our new data. All right, thank you for tuning in. You can create a custom annotation to validate a field. Spring Boot provides many standard annotations. You already use the not blank annotation, but sometimes what you're trying to validate is very specialized. For example, if I want to check if the score is a letter grade between A+ to F, this requires a custom constraint annotation, unless there's some standard annotation that exists that I don't know about. But as far as I know, this behavior is specialized and we need custom validation logic. So in this lesson, you will create a custom annotation for the score. Now the process is relatively simple. You need two things for a custom constraint annotation. You can define an annotation using the @interface keyword. And then you need to connect your annotation to validation logic. So we'll start with step 1, creating the annotation using the @interface keyword. So the first step is to say public @interface followed by what you want to name your annotation. And then for every annotation, you have to define a target. The target means where is this annotation going to be applied? Will you apply it to methods? Will you apply it to fields? Will you apply it to classes, to constructors? You also need to define a retention of runtime because we would want this annotation to be retained while we're running the application. So this is how you would define any annotation in Spring Boot. Let's go ahead and do just that. We'll create a new file, call it score.java. All right, as I create this class, it says public class score, but because we're creating an annotation, we have to say public @interface score. First thing we have to define is the target. What will this annotation bind to? Is it going to bind to constructors? Is it going to bind to methods, to fields? In this case, it's just going to bind to fields. Then we have to define the retention policy because we want this annotation to be retained during the runtime. This is how you would define any annotation in Spring. So now we can go ahead and apply this annotation to the score field. So we'll just say @score. All right. Now notice that I keep calling this annotation as opposed to a constraint validation annotation because we haven't applied any logic for this to be considered a constraint. Constraint annotations are more specialized in that you need to also explicitly specify that this is a constraint, and then here is where you would connect this constraint to validation logic. So here I have to actually specify that this annotation will actually serve as a constraint. All right. And I need to connect this constraint annotation to a class that implements validation logic. The way to do that is to write out the class name. In this case, I'm going to call my class score validator and follow this up with .class. Now, the score validator class does not exist yet. So what I'm going to have to do is create a new file called scorevalidator.java. I need to follow this up with validated by is equal to. All right. So this leads us to step 2, which is to actually connect our constraint annotation to validation logic. We've already connected it to a validator class. We just need to put some logic into it. So the first thing you have to do to create a validator class is to implement the constraint validator interface. The first parameter refers to the annotation type, and the second parameter is the type of value that we're validating. So here we're going to have to implement the constraint validator interface. The constraint validator, whose definition you can travel to, expects 2 parameters. So if you're using a Mac, press the Command key. If you're using a Windows, press the Control key. This applies to IntelliJ or VS Code. Click on the interface, and you can see it expects 2 parameters. The first parameter is the annotation that you're validating, in this case score. The second parameter is the type of value that you're validating. So we'll say the annotation is score. and the type of value is string. Splendid. Now, if you remember from my Java bootcamp, an interface is a contract of behavior. This was explained, I believe, in the polymorphism section. And what an interface does is it defines methods that a class needs to override. In this case, the method is valid. So go back here and override is valid. This method is really important because it's the heart of where the validation is actually happening. This method needs to return true if the score inputted by the user, if that value equals a letter grade from A+ to F. Otherwise, it must return false, meaning that there are errors. So what I'll start by doing is I will create a list of string values. We'll call it scores is equal to arrays dot as list. And here I'll say A+, A minus. I'll have to copy this 1, 2, 3, 4 times. Here we can just say F. Here we'll say B+, B minus, C+, C minus, D minus, D plus. Don't forget our commas. All right. And now I can create a simple for loop that compares the value inputted by the user against each value here. So I'll say for each to iterate over each string in the scores list. And I'll say if the value inputted by the user, make sure to use the equals method, not the equals operator because we're dealing with strings here. If the value equals one of the letter grades, then we'll return true. Otherwise, return false. And I think we're done. You created a custom constraint annotation, and then you connected it to a validator that implements the validation logic. This is how you would create any constraint annotation in Spring Boot. Now, there's just one last thing I need to address. Now, before we panic, I just want to say that in accordance with the Spring Boot documentation, when you're defining a constraint annotation, you must always define the groups and the payload parameters. Don't be frightened, just know that when you're creating a constraint annotation, you must always include these. The message parameter is interesting because what this does is if the user violates this constraint, then our binding result will retain this default error message, but we're actually going to override this message as we did before, and we'll say score must be a letter grade. So don't panic too much. I would just consider these boilerplate code that you need to include. All right, and now we have constraint annotations bound to each field. So when our handler method receives the post request, valid is going to validate 3 fields inside of our grade object, and the binding result is going to carry the result of that validation. It will carry the results for name, subject, and score, and it's going to send all of that data back to form. All right, if I go ahead and run the application now, we'll say localhost 8080. Leave the name blank, leave the score. You know what? Here we'll say R+. That's the example I typically default to. We'll leave the subject blank, press submit. Nice. Name cannot be blank, score must be a letter grade, and subject cannot be blank. The valid annotation uses the logic that we defined inside of the score validator to check if the value that was inputted by the user is it valid or not. In this case, is valid returned false, so valid determined that there was an error, and that error is eventually carried by the binding result sent over to our form, and our Thymeleaf errors attribute catches that error and displays it to the user. That's all. You added a constraint for each field, one custom constraint and two default ones. You need to divide your codebase into 3 layers. Let's face it, our code looks bad, like really bad. It's not even that long and it's already very messy. The code is messy because we're mixing the presentation logic, business logic, and data access logic in a single layer. You need to divide your codebase into 3 layers. And that's why in this lesson you will learn about the 3-layer architecture. A 3-layer design implies refactoring your codebase into 3 layers. One layer for presentation, one for business logic, and another for data access. Here's an example of a 3-layer design. A data store contains 2 grade objects. The user wishes to view all grades, so they make a GET request on the path/grades. A handler method that maps to the path/grades receives the request. The handler method needs to retrieve every grade from the data store. Retrieving an object from the data store is a CRUD operation. CRUD is any operation that creates, retrieves, updates, or deletes data from a data store. All CRUD operations should be inside the repository class. The repository class is the data access layer. The controller class and repository class do not communicate directly. The service class is the middleman between the two. The service class is also the business logic layer because it contains every business-related operation. In this design, the controller calls upon the service class, and the service class calls upon the repository class. The repository class fetches the data and sends it all the way back to the controller. After retrieving the data, you need to add that piece of data to the model, because the model is what populates your Thymeleaf template. Thymeleaf updates the view based on the data inside the model. The handler method responds with the view. And the controller's only concern is managing the model and presenting the view. Together, they make up the presentation layer. Currently, your code mixes presentation, business, and data logic in a single layer. The controller should only be concerned with presentation, but right now it's doing everything. We need to refactor our code. So to recap, you learned about the 3-layer architecture. The controller's only concern is managing the model and presenting the view. Together, all 3 of them make up the presentation layer. The service class makes up the business logic layer because it contains every business-related operation. The service class is also the middleman between the controller and the repository. Every CRUD operation on the data store should be inside the repository class. The repository class makes up the data layer. And so we're going to refactor our codebase into these 3 layers to ensure clean and scalable code. You should place every CRUD operation inside the repository class. CRUD is any operation that creates, retrieves, updates, or deletes data from a data store. Every CRUD operation should be inside the repository class. In this lesson, you're going to move every CRUD operation from the controller to the repository. Step 1 of the process is that the controller, service, and repository should be in separate folders. This is going to be your first step when dividing your codebase into 3 layers. In step 2, only the repository can access the data store. And in step 3, you need to move every CRUD operation from the controller to the repository. The controller class's only concern should be managing the model and presenting the view. Any operation that involves creating, retrieving, updating, or deleting data from the data store should happen inside repository. Step 1 is to create a repository class and a service class, and then place each one in a separate folder. So create a new folder called controller, and put the controller class inside. We're going to move it, and if you're using VS Code, make sure to press OK on refactoring changes. That way it performs all of the necessary imports for you, so that you don't have to do it yourself. Okay, now create a new folder called repository, and inside create a class called gradeRepository.java. And now create a new folder called service, and inside create a class called gradeService.java. Now step 2 is that only the repository can access the data store. In our case, the data store is an array list, and we need to remove it from the controller and place it inside the repository class. Perform the necessary imports. Remove this extra bracket. And now make the array list private so that no other class can access it. The controller class needs to get its data from grade repository. So inside the controller class, we need to create a new instance of grade repo. Grade repo is equal to a new instance of grade repository. All right. Now, step 3 is to move every CRUD operation from controller to repository. Remember that only the repository is allowed to create, retrieve, update, or delete data from the data store. You need to remove all CRUD operations from the controller class. The gradeForm method attempts to retrieve an object at a certain index. This is the R in CRUD, and all CRUD operations made against the data store should be inside repository. So inside gradeRepository, create a method that receives an index and returns an object, public grade, getGrade, that receives an index, and it's going to return the object at that index. Return studentgrades.get, the object at the index that gets passed in. And now the service class should be the middleman between controller and repository. But for now, forget about the service class. We're going to make direct calls from the controller to the repository. So here we'll say gradeRepository.getGrade at the index that we need. And now if we go down, the submit method tries to add an object to the data store. This represents the create operation in CRUD. So inside the repository class, we're going to create a method, public void add grade, that receives an object, grade, and adds it to the data store. grades, or I should say student grades, dot add the grade that gets passed in. If you took my Java course, you might be wondering, shouldn't I add a copy of the grade object? Well, typically in a real-life scenario, you would not be using an array list to store your data. You'd be using an actual database, so I wouldn't worry too much about that right now. Anyways, not important. Go back here and call grade repository dot add grade. Okay. The submit method also tries to update an object inside the data store. This represents the update operation in CRUD. So inside repository, create a new method called updateGrade that receives a grade object as well as an index. And it's going to update the array list with a grade at a particular index. Okay, and now here we can just say grade repository dot update grade. It also tries to retrieve every grade object from the data store. This represents the retrieve operation in CRUD, also known as the read operation. So inside repository, we're going to create another method that returns every single grade object, the entire list. We'll call it getGrades, and it will simply return the student grades. And now back here, call grade repository dot get grades. And inside of get grade index. The last step is to rerun your code to make sure that everything still works. All right, we'll say localhost 8080. We will submit a grade, Harry, A-, potions. We will try to update that student's grade. We'll give them a C-. We'll give them an invalid grade. All right, everything still works. Refactoring your code obviously does not change any of its logic, but it does make your code a lot cleaner and easier to scale. So to recap, you moved CRUD-related operations to the repository class. The repository represents the data access layer. Only it has access to the data store. Also, only it is allowed to create, retrieve, update, or delete the store. That's why we moved every CRUD operation from the controller to the repository. The service class is the middle layer of a 3-layer code base. The service class is the middleman between the repository and the controller. It also contains every business-related operation. So in this lesson, you will finally refactor your code into 3 parts. Going through the process, the controller class and repository should not communicate directly. The service class must act as a middleman between the two. Any calls to the repository will first pass by the service class. Step 2 is to move every business-related operation from the controller into service. The controller class's only concern should be managing the model and presenting the view. We already stripped the controller class of CRUD-related operations, and now the next step is to strip it from business-related logic. The service class should act as a middleman between the controller and the repository. The controller and repository should not communicate directly. The layer that handles the business logic should be the one that communicates with the repo. So the controller communicates with the service, and the service in turn communicates with the repository. So what we'll do is inside the controller class, create a new instance of grade service. Grade service is equal to a new grade service object. And now because grade service is the middleman between the repo and the controller, we're going to call the methods from grade service instead. And we will have to copy all of these functions into grade service. Now, of course, you cannot make CRUD operations anywhere except the grade repo. So here we're going to have to create an instance of the grade repository. Grade repo is equal to a new grade repository object. We can do the same thing all over. All right, perform the necessary imports. Here is an example of a computation. This logic does not belong in the controller. So inside service, we're going to add a new method called getGradeIndex that returns an index upon receiving an ID. And what we can do is delete all of the logic from controller and place it inside of service. We're already inside of grade service, so we can remove that. And we'll have to import the constants class. Make sure you import the right class. There are so many things you can import, but make sure you import the right one. Okay, and now going back to grade controller, call gradeService.getGradeIndex wherever you need to. Okay, and now this is an example of a decision-making process. First, it looks for an index based on an ID, and if the index leads to no result, then it returns a new grade object. Otherwise, it retrieves a grade object at a particular index. This is business logic, and it does not belong in the controller. So what we'll do is inside the service class, add a new method called getGradeById. Public grade getGradeById that returns an object once it receives an ID. Okay, now you can remove the logic from the controller, or you know what, don't remove it yet, just copy and paste it. We'll go back to it. We're already inside of grade service, so we're good here. And now what we have to do is return a grade based on the index that we get. So if the index is equal to invalid, return a new grade. Otherwise, call the getGrade function. And now back in the controller, I can remove all of this logic and just say model.addAttribute grade and call gradeService.getGradeIndex. get grade by ID. Beautiful. Now, submitting a grade also involves a decision-making process. If the index yields no meaningful result, it adds a grade. Otherwise, it updates the grade at a particular index. This logic does not belong in the controller. So inside the service class, what I'm going to do is add a new method called submitGrade. Public void submitGrade that's going to take care of all the business logic. It's going to receive a grade object. And then inside, we can just copy and paste the logic from the controller and make the changes where necessary. So we don't have to call grade service here. We can just say add grade and update grade. All right, and now back in grade controller, I can just say grade service dot submit grade. And this is looking pretty good. Look at how much better the code looks. The only thing the controller is doing is managing the model and presenting the view. The service class contains all of the business logic and is the middleman between the controller and the repo. The repo performs the CRUD-related operations on the data store. I have to say, we've come a long way in the past 2 lessons. So to recap, you refactored your codebase into 3 layers. We stripped the controller class of CRUD-related operations and placed them inside the repo. We removed all of the business logic and placed them inside the service class. The layer that handles the business logic should be the one that communicates with the repo. So service is also the middleman between the controller and the repository. The controller communicates with the service, which in turn communicates with the repository. The 3-layer design ensures that your code is clean and easier to scale. And as you can tell right now, the code is really clean. A bean is an object, nothing more. A bean is an object that Spring stores and manages for you. In this lesson, you will learn what a bean is. Let's go over the most common way of creating a bean. A component class is automatically discovered by Spring Boot. When you run a Spring Boot application, it does 3 things. One of them is a component scan. That is, it scans your project for component classes, and so any class annotated with component is automatically discovered. Spring Boot creates an object out of each component class that it finds. A Spring container, also called the application context, stores and manages the object for you. The object lives inside of the Spring container. And that being said, an object that lives inside the Spring container is called a bean. The Spring container stores and manages the object for you. To recap, you learned what a bean is. A bean is an object that lives inside of the Spring container, also known as the application context. The Spring container manages the object for you. Beans allow for dependency injection. Never ever create an object inside of a class that depends on it. This is called tight coupling, and it makes unit testing impossible. Instead, you should inject the object into the class. In this lesson, you will use dependency injection to achieve loose coupling. So, what is tight coupling and when does it happen? Tight coupling happens when you create an object inside of a dependent class. An object that another class depends on is called a dependency. In this example, grade controller relies on the grade service dependency. But you should never create a dependency inside of its dependent class. Your code will become interconnected and impossible to unit test. We will talk about unit testing in the next section, but for now, just know that tight coupling makes unit testing impossible. The solution is dependency injection, so let's go over the process. The first step is to annotate the class using @component. Spring Boot scans for components, and it turns the component class into a Spring bean. In other words, the moment you run your application, Spring Boot performs a component scan, discovers this one, creates an object out of this class, and stores it inside the Spring container. And then AutoWired injects the bean into the class that needs it. Your controller class depends on a grade service object. Instead of setting the field equal to a new object, AutoWired wires the grade service bean into it. Grade controller depends on a grade service object. So the first step is to annotate your dependency using the component annotation. As soon as you run your application, Spring Boot is going to register this component as a bean. Spring Boot is going to create an object out of this grade service class, and it's going to store it inside of the Spring container. And so now what we can do is use AutoWired to wire the bean into the grade service field. If we rerun the application and make some requests, everything still works. Instead of creating the object directly inside the class, we're injecting it directly from the Spring container. This is great, but our code is still tightly coupled. The service creates the repository object that it depends on. Again, the dependent class should never create its own dependency. We can delegate that task to Spring Boot by annotating the repository class with the component annotation. Spring Boot will register grade repository as a bean, and so now we can use AutoWired to wire the bean into the service class. All right. Everything should still work. So to recap, you achieved loose coupling by injecting a dependency. Never ever create a dependency inside of a dependent class. Your code will become tightly coupled and impossible to unit test. Instead, inject your dependency from the Spring container. Creating this type of loose coupling in your app makes your code a lot easier to test. You can also achieve dependency injection with the service and repository annotations. The component annotation is too generic. You should use the service and repository annotations instead. In this lesson, you will do just that. You will use the service and repository annotations. Now, service, repository, component, they are all the same. Service and repository are no different than component. Any of these annotations will turn a class into a bean. We used the component annotation everywhere and it worked fine. But it's good practice to mark the service class using the service annotation. And the repository class using the repository annotation. It makes your code easier to read. I can quickly look at the annotation and know that this is the service layer, and this is the repository layer. Now, fun fact, controller also derives from component. Spring Boot scans your project for component classes. Because controller derives from component, it turns GradeController into a bean. The GradeController bean is just an object that lives inside of the Spring container. And from the Spring container, Spring Boot manages the GradeController bean behind the scenes, and that's why it seems like magic when it's able to handle web requests. GradeController uses its specialized handler methods to serve web requests. Grade service is a bean. Grade repository is a bean. AutoWired injects the grade service bean into one of GradeController's fields, and in turn, AutoWired injects the grade repository bean into one of the grade services fields. So to recap, you used service and repository instead of component. Service and repository are no different than component. Any of these annotations will register their class as a bean. Although we could use component for every class, it's good practice to use service for the business logic layer and repository for the data access layer. You can also register beans with the bean annotation. You can register a bean with two types of annotations: component and component derivatives like service or repo, and bean. In this lesson, you will register a bean with a bean definition. So, going through the process, step 1 is to create a bean definition. A bean definition is an annotated method that returns a dependency. Configuration marks the class as a source for bean definitions. So Spring is going to know to find the beans here, create them, and add them to the Spring container. And then, as always, AutoWired wires the bean into the class that needs it. For the time being, remove the repository annotation. We can register the repository as a bean using the bean definition. So first, what you must do is create a class called appconfig. So first create a file called appconfig.java. And this class is responsible for registering beans. First, we'll create a method that returns a grade repository object, grade repo. This method will return a new object of the grade repository class. We're going to mark this method as a bean definition. The last step is to annotate the app config class with @configuration. Spring adds the object that the bean definition returns inside the Spring container. And then, as always, AutoWired wires the bean wherever it's needed. So if you run your application, let's make sure everything still works. We'll go back to the form. We'll say Harry, A+, potions, everything is still fine. All right. Now this is great, but I don't really like registering beans like this. It's so much work for something we can easily accomplish with the component annotation. So I'm actually going to delete app-config and restore the component annotation, or the component derivative, in this case repository. So to recap, you registered a bean using a bean definition. Configuration marks the class as a source for bean definitions. So Spring is going to know to find the beans here, create them, and add them to the Spring container. And then, as always, AutoWired wires the bean into the class that needs it. Everything appears to be magical until we apply breakpoints and trace the runtime step by step. So what I'm going to do is apply breakpoints at the heart of our application, which is the grade controller. I will apply some breakpoints pretty much everywhere. Okay, and now I think I'm ready to run the app in debug mode. Probably should have ran by now, so I'll go to localhost 8080. You probably noticed by now the this keyword. This means current object. So as soon as we ran our Spring Boot application, it performed a component scan. Controller is a derivative of component, but it's more specialized because it can also handle web requests. But anyways, this class was scanned by our Spring Boot application, and upon startup, an object was created of the grade controller class, and right now we are inside the current grade controller object. And now you'll notice if you expand this, the grade controller object has a grade service object. Once again, upon application startup, it scanned for components. The service annotation is a derivative of component. So a grade service bean was created and is being managed inside the Spring container. And this grade service bean was auto-wired inside of this grade service variable. Now, if you go even further, the grade service object has a grade repository object. Again, upon application startup, it performed a component scan. Repository is a component derivative, so a grade repository bean was created and is currently being managed inside of the Spring container, but this same bean was auto-wired into the grade repository variable. So you can say that grade controller, instead of creating a grade service object, it's using a grade service object that already lives inside of the Spring container. It's leveraging a Spring bean. And from this grade service object, we can make calls to get grade by ID, in order to get an index. Then based on this index, it will return an object. So everything still works exactly the same way as before. Instead of creating its own object, it is simply using an object that already exists. If I press next, it returns the form. I'll go ahead and submit something. Let's say Harry, C-, and we'll do everything correctly this time. Potions. All right, there are no errors, so we can step into the next breakpoint. And now I can call submit grade from our grade service object. I can step inside of this function. I'll step over this line. The index is -1000, so this will execute. Add grade leverages the grade repository bean. And add grade, I will step inside of this function. And here, like before, the grade service object is not creating its own instance of the grade repository. It's simply using an instance of grade repository that already exists inside of the Spring container. And using this grade repository object, this grade repository bean, we can call get grades. I won't step inside, I'm just going to step over this. And here you can see that it has added a grade to the student grades array list. All right, everything still works exactly the same way as before. Now it redirects them to make a get request on /grades. It will do exactly that. And it will call get grades from the grade service object, stepping into that. This is going to call get grades from the grade repository object, and it's going to return the student grades. Here you can visualize the return value. There is only one grade, so it follows that the grades template will just return a single grade. Beautiful. So just to really drive home the point, instead of creating our own objects, these objects already exist behind the scenes. We're just wiring them in. That being said, an object that we wire in from the Spring container is a bean. Dependency injection is very important for unit testing. You cannot unit test service when it's tightly coupled to its dependencies. Service becomes unit testable when it's loosely coupled to its dependencies. On one hand, the service is creating its dependency, and on the other hand, the dependency already exists inside the Spring container as a bean. The service is simply using it. Anyways, what should we unit test? We should unit test the service because it contains all of your business logic. Business logic is most prone to bugs. In other words, we're going to need a service test class that's entirely devoted to testing the service class. The test class contains a unit test for every meaningful piece of logic inside of grade service. If ever unit test passes, then you can rest assured that the grade service doesn't have any bugs. If one of your tests fails, then there's a bug inside of grade service, so you'll need to fix your code until the unit test passes. Once it passes, you'll know that you fixed your bug. Now here's the catch. You cannot test the service class when it's tightly coupled to its dependencies. We need a service test class that's entirely devoted to testing only the service class and nothing else. In a tightly coupled scenario, grade service creates its own repository dependency. The goal is to test grade service in complete isolation. But the dependency is a disturbance. The dependency returns data based on logic defined in the repository class. It interferes with our unit test because we only want to test the logic inside of grade service. Tight coupling means we can never test a grade service in complete isolation. That's why loose coupling is important. In loose coupling, the class does not create a dependency. Rather, the dependency already exists inside of the Spring container. We're simply using it. Spring injects a bean into the variable. And so you can achieve dependency injection using AutoWired. But the thing is, when you're unit testing, you're not actually starting up the Spring Boot app. You're only running the test class and nothing else. There is no mechanism for component scanning, there is no Spring container, which means there are no beans to inject. So when you're testing, this variable is actually null. But because the service class is loosely coupled, we can inject a mock into the variable instead. The mock can mimic the behavior of a dependency, but it doesn't have any logic of its own. From the testing class, we can completely control what the mock can or can't return. So ultimately, using a mock allows you to test grade service in complete isolation. So to recap, you can only unit test a class when it's loosely coupled. If service is tightly coupled to its dependency, then you're stuck with it. You can never test grade service in isolation. The dependency's logic will always interfere with the grade service logic that we want to test. If the service is loosely coupled, then we can inject a mock instead. The mock doesn't have any logic of its own, so we can test grade service in complete isolation. It's important to unit test every meaningful method inside of the service class. The methods inside of the service class contain business logic, and business logic is very vulnerable to bugs. It's irresponsible to add any more business logic without unit testing first, because unit tests will make sure that you never get any bugs. In this lesson, you will set up a class that can unit test grade service. So let's go through the process. First, you're going to create a class called grade service test. This class is going to unit test every meaningful method inside of grade service. So in our code, what I want you to do is go to source/test, and inside of the grade submission folder, create a new file called grade service. So the same name as the class that we want to test, followed by the test suffix .java. All right, now runWith runs every unit test inside of grade service test using the Mockito JUnit runner. A class that can run tests is called a runner class. So what we have to do is make this class into a runner class, and we can do that using the runWith annotation. And I seem to have forgotten something. And the thing that I'm forgetting is that runWith is provided by the JUnit dependency. So we can go and look up JUnit dependency, go to the central Maven repository, grab it, copy and paste it into your project. All right, ideally the change in this build file should synchronize. So let's see if I can access the run with annotation. There you go, cool. And we will run this test class using the Mockito JUnit runner. Okay, step 3 is to use mock to create a mock of grade repository. A mock can mimic the behavior of grade repository while having no logic of its own. Now, there's a difference between starting up an entire Spring Boot application, which scans for components, configures the Spring container, registers beans, as opposed to just running a single test class. The service class that we need to test relies on a repository dependency. But when you're testing, the repository bean doesn't exist. But we still need to auto-wire this variable to something, otherwise it's going to be null. So what we're going to do is create a mock of the repository using the mock annotation. This mock will mimic the grade repository dependency while having no logic of its own. Yet, we still need to inject this mock into the grade repository variable. How do we do it? Inject mocks creates an object and injects the mock into it. In this case, inject mocks creates an object out of the class that you want to test. It also injects the grade repository mock into the grade service object. So in your code, what I'm going to do is define a grade service variable, private grade service, and then I'm going to annotate it with inject mocks. Inject mocks is going to create an object of the grade service class, and it's going to inject the repository mock into it. In this lesson, you set up a class that can unit test grade service. Run with runs every unit test inside of the runner class. Right now, we don't have any unit tests. The runner class has no mechanism for scanning components and creating beans, so the repository bean for grade service doesn't exist. In inject mocks, what we're doing is we're creating a grade service object, and it auto-wires the grade repository mock into a variable that would otherwise be null. The mock can mimic the behavior of a dependency without having any logic of its own. This allows you to test grade service in complete isolation as you control exactly what the mock can or can't return. It's necessary to test all of the business logic inside of the service class. In the last lesson, we set up a class that mocks the grade repository dependency. It creates a real object out of grade service, and then it injects the grade repository mock into it. We're essentially wiring this grade repository mock into the following variable. This allows us to test grade service in complete isolation because we can control exactly what the mock can or can't return. In this lesson, you will unit test every single meaningful method inside of grade service. The unit testing process is fairly simple. The test annotation tells JUnit to run the method as a unit test. And there are 3 steps to writing a unit test. Arrange means mock the data that's needed to carry out the unit test. You kind of just prepare everything until you're ready to act, until you're ready to call the actual method that you want to test. After you call your method, you need to assert, you need to check if it's actually behaving correctly. So we're going to start by testing if getGrades is actually able to retrieve the grades from the repository. The test annotation tells JUnit to treat the method that follows as a test. We're going to call the method getGrades from repo test. Okay, Step 1 is to mock the data that's needed to carry out the unit test. The nice thing is telling the mock what data to return reads like English. For example, when the service calls gradeRepo.getGrades, then it should return a list of grades. This translates to the following code. So inside the unit test, we're going to write when the service object calls the grade repository mock.getGrades, then we're going to want this to return an array list. Then return arrays.asList, and the array list that it returns will contain two objects. The first grade object will be Harry, Potions, C-. The second one will be Hermione, Arithmancy, A+. Now that we've prepared the data, the next step is to act. The next step is to call the method that you want to test. The method that we want to test is gradeService.getGrades. And we want to test if it's actually able to retrieve the grades from the repo. We're going to store the result in an array list. List grade result is equal to whatever comes from gradeService.getGrades. And now that we've called the method that we want to test, the last step is to assert, is it actually behaving correctly? In other words, we're going to perform a sanity check that ensures gradeService.getGrades is actually getting the grades from gradeRepo.getGrades. And we can do that with an assertion. We'll say assert equals, and here we compare the value that we're expecting against the actual value. So I expect the name at index 0 to equal Harry, and then the actual value is going to be the name at index 0. Let's perform another assertion. I expect the subject at index 1 to be Arithmancy, and the actual value is going to be the subject at index 1. Run your test, and the assertion passes. This confirms that gradeService.getGrades is actually getting the grades from gradeRepo.getGrades. Now, before we continue, I want to emphasize that we didn't actually need to test gradeService.getGrades because the code here is very trivial, which leads me to my rule of thumb. Only unit test methods that offer meaningful logic. I only unit tested getGrades as an example of arranging the data that you need for your test, acting on that data by calling the method you want to test, and then making assertions to make sure that the method you're testing actually works. That being said, we're not going to be testing the following methods because the code inside is very simple and I'm pretty sure it works. That leads us to unit test number 2. We're going to test if getGradeIndex is able to return the correct index when it receives an ID. This method contains meaningful business logic, which makes it vulnerable to bugs, and it's really important to write a unit test that ensures it's behaving correctly. As before, the test annotation tells JUnit to treat the method that follows as a test, and I'm going to call the method gradeIndexTest. Now, step 1 is to mock the data that's needed to carry out the unit test. If you look inside of gradeService.getGradeIndex, it calls getGrades, and in turn, getGrades calls gradeRepo.getGrades. So we need to mock the data that this method returns. We can just copy and paste what we had before. When gradeRepo.getGrades gets called, we want it to return the following array list. And for us to be able to test getGradeIndex, we need to pass in a bunch of IDs. So we're going to need access to the data store. So we'll need to call gradeService.getGrades before we can even start testing getGradeIndex, because we need to grab the ID of each grade, and we'll just store this in a result variable. Okay, step 1 is done. We've already mocked the data that's needed to carry out the test. And now step 2 is to act. We need to call the getGradeIndex function to make sure that it's working correctly. We'll say gradeService.getGradeIndex. The first ID we're going to pass in is the one for Harry. And the second ID we're going to pass in is invalid. I'll just say 1, 2, 3. So I'll store the return value here into a variable called valid, and I'll store the return value here in a variable called not found. Okay, the last step is to assert, is to check if getGradeIndex is behaving correctly. We can do that with an assertion. So using assert equals, we expect the valid index to be 0. So when we give getGradeIndex Harry's ID, we expect it to return an index of 0, but will it? Let's find out. And we'll make another assertion. Here we expect that if we give getGradeIndex some random ID, then it's going to return constants.notFound. So we're going to make sure constants.notFound is what this notFound variable equals. And we get a null pointer exception. What could that be? Well, thankfully, this leads me to something else in that we can set up breakpoints. So upon calling getGradeIndex, we're getting a null pointer exception. What I'll do is I will debug my test, and I'm going to step inside getGradeIndex. Press the step inside button. Okay, I'm going to step out and step back in. All right, step out, step back in now, and it works. So this ID belongs to Harry. First, it loops through getGrades. Interesting, here it's calling getGrade. If I put a breakpoint here, we completely forgot to mock what getGrade should return when it's called. So what it's doing is it's returning a null. GetGrade returns a null, and attempting to call a method from a null results in a null pointer exception. So we actually didn't finish step 1. We mocked what gradeRepo.getGrades should return, but we didn't mock what this method should return. So we're going to have to stop our test and fix it up. So what I'm going to do, just to keep things simple, is here we'll say grade is equal to a new grade. We'll copy this over. And instead of this returning an array list of 2 grades, it will just return 1. There's no need to return 2. And now I can mock the data that gradeRepo.getGrade should return when it's called. So here we'll say when gradeRepository.getGrade at index 0, then it should return the following grade. Okay, we don't need this anymore. Here we can just say grade.getID. Okay, so now we've properly applied step 1, which is to mock the data that's needed to carry out the unit test. When gradeRepo.getGrades it's called, then it should return an array list. When gradeRepo.getGrade gets called for an index of 0, then it should return the following grade. Okay, so now we've successfully mocked the data that's needed to carry out the unit test. And here we're checking when grade service calls getGradeIndex, is it actually able to get an index of 0? And then we're checking if grade service calls getGradeIndex for an ID of 1, 2, 3, is it actually able to get a constants.notFound? Running our test. And it works out. Beautiful. So now test number 3 is to check if getGradeById is returning the correct grade when you give it an ID. So we'll create a new test. We will call the test return grade by ID test. Step 1 is to mock the data that's needed to carry out this test. So we're just going to copy what we have over here. Because if you look inside of getGradeById, it calls grade index, which in turn calls getGrades as well as getGrade. So we need to mock what these methods return when they are called. Okay, now that we've prepared the data, the next step is to act. The next step is to call the method that you want to test. So first, we're going to grab the grade's ID and store it in a string variable. String ID is equal to grade.getID. Then we'll call gradeService.getGradeById and store the result in a grade variable. So here we'll say grade result is equal to the return value. Okay, the last step is to check if getGradeById is behaving correctly, and we can do that with an assertion. We're going to use assert equals, and we expect the grade that gets returned to equal the following object. When we pass in the following ID, we expect getGradeById to return the correct results. The result that we're expecting is this grade, and we're going to see if that's the actual case. Nice, getGradeById is working correctly. Now let's unit test our fourth method. We're going to check if submitGrade is able to actually add a grade. This method contains two things to test. The first test is to verify the addition of a new grade. So like before, we're going to have to go back and create another test. We'll say public void add grade test. And like before, we need to mock what getGrades and getGrade return. So we can just use the following code to prepare the data. This test will check if submitGrade calls addGrade if the index isn't found. So the next step is to call the method that you want to test. We're going to create a new grade that doesn't already exist. We'll say grade new grade is equal to a new grade object. We'll say Hermione arithmancy A+. And then we'll submit the grade. GradeService.submitGrade. New grade. And how can we test if this works? How can we test if submitGrade is actually calling addGrade? The verify assertion can verify how many times something happened. It accepts 3 arguments: the mock, how many times you expect a mocks method to be called, as well as the method. We're going to verify that addGrade gets called at least once when we submit a new grade that doesn't exist in our data store. So we'll say verify. First, you pass in your mock, grade repo mock. We're going to check if the method gets called once, times, not timeout. The wanted number of invocations is 1, and we're going to check if addGrade new grade gets called at least once. Run your test, and it does. So we can rest assured that submitGrade is working correctly. When you submit a new grade that doesn't exist inside of your data store, then it's going to call addGrade. All right. Unit test number 5 is to test if submitGrade is updating an existing grade. Like before, I'm going to create another test. We'll say public void update grade test. And we can prepare the data in much the same way. When this gets called, we want it to return an array list of one grade. When this gets called, we want it to return that same grade. And now step number 2 is to actually call the method that you want to test, the method that you're actually interested in. What we're going to do is we'll say grade service dot submit grade, and we'll resubmit the grade. But before that, we'll say grade dot set score, and we'll set it equal to an A-. Okay, and once again, we can verify how many times something happened. We're going to verify if grade repo mock dot update grade gets called at least once. So the mock is grade repository. We're going to check the wanted number of invocations is 1, and we're going to check if update grade for the following grade at index 0, does this function get called when we submit an existing grade? Run your test, and it does. This confirms that when you pass in an existing grade into submit grade, it calls the appropriate method. When you pass a method that doesn't exist already inside of the data store, inside of submit grade, then it's going to call the add grade method. All right, if I were to run every single test in my class, they all pass, which confirms that every method inside of grade service is working correctly. We tested submit grade, get grade by ID, get grade index. We also tested get grades, which we really shouldn't have because it was really trivial. But anyways, we can rest assured that our application, or our grade service class for that matter, doesn't have any bugs. In this lesson, you wrote a unit test for every meaningful method inside of grade service. The passing test cases imply that our methods are behaving correctly, and we can rest assured that there aren't any bugs. Integration testing is useful for testing the entire application. A unit test checks if one small unit of your apps is working as it should, whereas an integration test maps the entire request and response lifecycle. In this lesson, you will learn the difference between unit and integration testing. A unit test verifies a small individual unit of your application. Unit testing is the process of testing a single unit or a small portion of code to verify that it's behaving as it should. You need a unit test for every method that provides meaningful logic. Now, having a test for individual units of your application increases your confidence in modifying the code. Because if every test passes, then your business logic works. If you make a mistake, one of your unit tests is going to fail, and the failing test will prompt you to fix your mistake until it passes again. Now, an integration test maps the entire request and response lifecycle. An integration test traverses all of the application's layers. First, it makes a mock request to a handler method. Business-related operations occur in the business logic layer, and data access in the data layer. After the test maps the entire request and response lifecycle, it will make assertions. Typically, the assertions involve the response, the view, and the model. There is no Spring container, there is no Spring context when you're unit testing. A unit test verifies a method in complete isolation. so it doesn't need a Spring container. We can just mock all of our dependencies using JUnit. Now, you need the Spring context. You need the Spring container when integration testing. An integration test traverses all of the application's layers from the controller to the repository, so it needs access to all of the beans inside of the Spring container. Last thing to know is always create 4 integration tests. An integration test verifies the interaction of every component in your application. It doesn't make any sense to verify the interaction of these components when the business logic is defective. So first, you should unit test every meaningful piece of business logic inside of your service, and once you're certain that the business logic is behaving as it should, then integration tests can verify the interaction of different layers in your application. So to recap, an integration test maps the entire request and response lifecycle. There is no Spring container when unit testing. You do not need beans when testing one method in complete isolation. You need the Spring context. You need the Spring container when integration testing. An integration test traverses all of the application's layers from the controller to the repository. And finally, unit testing comes before integration testing. In this lesson, you will set up a class that can run integration tests. You'll notice that your project comes with a test class that is annotated with Spring Boot test. The Spring Boot test annotation is for integration testing. Because integration testing spans the controller, the repository, the service, it's going to need beans. The Spring Boot test annotation loads the Spring container, it loads the Spring context, it will scan your entire application for components and register them as beans. So at this point, the grade controller bean lives inside of the Spring container, which means we can auto-wire it. We're going to auto-wire the grade controller bean inside of a controller variable. And now after it loads the Spring container, after it loads the Spring context, this lifecycle method context_loads is going to run. Here we can perform a sanity check and verify that the controller is not null. Was a bean actually injected into the following variable? So we can say assert that, is assert that deprecated? Interesting. Never mind, we'll just say assert not null. And we will assert that the controller is not null. A bean was injected into it. All right, I think it worked, and it did. Our test passes. We successfully loaded the Spring container and then auto-wired the controller bean. Now the next step is to configure the MockMVC. You need MockMVC in order to mock a GET or POST request against one of your controller's handler methods. The beauty about MockMVC is that you can test how your app handles web requests without running or deploying your application. So what you'll do is you will annotate your class with autoconfigure MockMVC. And as the name suggests, this is going to auto-configure your MockMVC. In other words, to be more specific, this will register the MockMVC bean inside of the Spring container. It's going to live as an object inside of the Spring context, which means we can auto-wire the MockMVC bean right here. We will auto-wire the MockMVC bean into the following variable. And after the context loads, we can verify that the MockMVC bean is not null. Assert not null, MockMVC. Both assertions pass, which means that both objects are not null, and we're off to a really good start. Now we don't actually need to auto-wire the controller bean. This was just for demonstration purposes, so remove it. And that's all. So to recap, you set up a class that can run integration tests. Spring Boot test starts up the application by loading the Spring Boot context and scanning for beans. You also annotated the class with autoconfigure MockMVC. This annotation, as the name suggests, autoconfigures your MockMVC. It's going to register the MockMVC bean inside of the Spring container, which is subsequently auto-wired, and now we're ready to use MockMVC in order to make mock requests. See you soon. Let's just jump right into it and write some integration tests. Now, before anything, we need to identify the type of web requests that can be made. There are three. A GET request can be made on an empty path, and that request can include an ID parameter. A GET request can be made on handle submit. Looking back, I should have called the handler method handle submit and specified a path of submit form. I don't know why I got that backwards, but anyway, let's just roll with what we have. Doesn't really matter all that much. And we have another web request that is made on /grades. So step 1 is going to be to perform a mock request that simulates, and step 2 is going to be to make assertions with respect to the model, view, and status. As the test maps the entire request and response lifecycle, the assertions will verify if different parts of your app were interacting as they should. So let's start with step 1. First, we will perform a mock request on the empty path and include an ID parameter in that request. So over here, instead of running the app and going on localhost 8080, we're going to create an integration test. Public void, and this test is going to verify that grade form behaves correctly as it handles web requests made on an empty path. So I'll call this test show grade form. And now I can build a mock request using a request builder. I can say request builder request is equal to MockMVC request builders dot get, and we're going to make a get request on an empty path and include an ID equals to 123. All right. Now the ID you pass in doesn't really matter because the handler method is going to call GradeService.getGradeById, which is capable of handling invalid IDs. But now we can use MockMVC to perform a mock request. I can say MockMVC.perform, and it's going to make a request. Oh, I called this request builder. Let me call it request. That's more intuitive. And I think this is beautiful because we're able to mock a GET request without actually running the application and going on localhost 8080. The test is going to traverse all of the application's layers, starting from the controller, which is going to call upon the grade service, which is going to call upon the repository. So this test is going to travel all of our application's layers, which brings us to step 2. You need to make assertions with respect to the model, view, and status. The assertions will verify if components across all layers of your app are working as they should. The reason we have an error is because this throws a checked exception. Let's just say throws exception here and get rid of it. All right. And now after making the request, I expect the status to be successful. I always have trouble importing the status, so I'm just going to leave you this import. Anyways, I expect the status to be successful. I expect the view that's returned. This isn't importing either. You know what? Let's just import everything from MockMVC result matchers. Okay. I expect the view returned to be named form. And I expect the model to have an attribute exists called grade. This is the object that's going to back our form data. Now I can run my integration test. And it passes. Now I have confidence that the app can successfully handle GET requests made on an empty path. All right. Next thing we're going to do is perform a mock request on the path handle submit. The next test we write will validate the lifecycle of a successful submission. So I'll go back and create an integration test that is capable of making post requests. I will call the integration test successful submission. Let's just throw the exception right now. As before, you can build a mock request using the request builder. Request builder, request is equal to mock MVC request builders dot post, because we'll be making a post request. And the post request will be made on the path handle submit. I really wish I had called this submit form because that would make a lot more sense. But anyways, the handler method for handle submit, it expects a valid grade object. So by default, this handler method, it will create a grade object using your empty constructor, but then it needs to update every single field in that object with payload from the post request. So we still need to pass in the name, the subject, and the score fields right here. And we can do that by saying .param. We need to pass in a name. We'll say Harry. Pass in a subject. Say potions. And pass in a score. We'll say C-. Now, just like we did with the form, make sure the parameters you pass into the post request match the fields of your POJO. Now we can use to perform the post request. I'll say MockMVC dot perform. It will perform the post request. Now, by the end of this post request, we expect a redirection. Now, let's just say that we make the post request and it's successful. The grade object is going to be valid. The binding result won't have any errors. So we expect a redirection by the very end. So here we'll say and expect status dot is redirection. Run the test. And it passes. Beautiful. All right, and then we can say we expect the redirected URL to be /grades. Yeah, it's /grades. Of course it is. All right, if both of these pass, now I'm confident that if the user enters valid data, the application will respond appropriately by redirecting them to the grades view. Now, what if the user enters invalid data? How is our app going to behave? Once again, we can use an integration test. We'll say public void test unsuccessful submission, throws exception. Oops. This test will validate the lifecycle of an unsuccessful submission. And as before, you can build a mock request using a request builder. We'll say request builder, request is equal to MockMVC request builders dot post. We're going to make a post request on handle submit. All right, and we're going to pass parameters into the post request, but they're going to be invalid. So we'll say blank, blank, and we'll put in an invalid grade of R+. And let's perform the post request. We'll say MockMVC.perform. And upon performing this request, we expect the grade to be invalid. The binding result is going to have errors. The view returned will be the form. So the status is still going to be 200 successful. However, the view returned is going to be the form. And if the form is returned, then that's a clear indication that our handler method did not accept the user's garbage data, and it prompted them to go back and resubmit it. So let's run this integration test. And our test passes. Now I'm fully confident that my post mapping can correctly handle successful and unsuccessful submissions. Okay, the last thing we're going to mock is a request on /grades. As before, I will create an integration test, public void, and I'm going to call it test get grades, throws exception. Like always, I will build a mock request using the request builder is equal to MockMVC request builders dot get, and I will make a get request on /grades. Now we can use MockMVC to perform the get request, MockMVC.perform. All right. Again, this is beautiful how we're able to simulate a GET request without actually running the application and going on localhost. Anyways, now we're going to make assertions with respect to the model view and status. So by the end of the request and response, what we're expecting is a status of 200. The view returned must be grades. And the model must contain a grades attribute. Model attribute exists grades, because that grades attribute is needed to populate the grades table. And if you run this test, it passes. This gives me a lot of confidence that a request made on the path /grades will return the right view and the right data. With this last test, we successfully validated the interaction of different layers in the app. We mocked every web request the user can make, and by the end of the request response lifecycle, as it traversed all of the application's layers, we verified the model, we verified the view, and we verified the status. Welcome to another Breakpoint session. In this one, it would be nice to trace the runtime and see how exactly does an integration test map the request and response lifecycle. First, an integration test starts by performing a mock request that is going to be intercepted by one of your handler methods. I already went ahead and added breakpoints to the 3 handler methods that we have in the controller. So here, what I'll do is I will run this test in debug mode. All right, beautiful. It performs a mock request on an empty path, and it passes in an ID that equals 123. The handler method grade_form will intercept the request made on this empty path, and it will receive the ID that equals 123. But the ID that gets passed in doesn't really matter because this will either return an empty object or it will return an object that's pre-populated. But anyways, the object that gets returned will be added to our model. Thymeleaf can use it from there. And then our handler method will successfully return the form view. If we go back, our test should pass because the response was successful, the view returned was the form, and the model did have an attribute grade that acted as a form backing object. So now we can rest assured that when our application receives requests made on an empty path, it's going to behave correctly. The integration test that follows will test for a successful submission. So what this is going to do is perform a post request on the path handle submit, and it's going to pass in 3 parameters: a name, a subject, and a score. All right. Our handler method intercepts the post request that was made on handle submit, and as soon as it does, it's going to create an empty grade object and populate it with fields from payload in the post request. All of the payload that was passed in was valid, so it follows that our binding result isn't going to have any errors. There are 0 errors, so we can rest assured that when a user passes in correct data, our handler method is not going to return the form, it's going to submit the grade, and then it's going to redirect them to another request on /grades. So our test passes because it was expecting a redirection, and it was expecting the redirected URL to be on /grades. So now our test reassures us that when a user enters valid data, the submission will be successful. But what if they enter invalid data? Let's run this in debug mode. Once again, our handler method receives the post request made on /handle submit. The parameters that were passed into the post request were garbage data. In this case, as submit form creates a new grade object and tries to populate it with values from the payload, the validation will fail and our binding result will carry 3 errors. Because the result has errors, it's going to return the form. And our test passes because that's exactly what it was expecting. It was expecting that when a user enters garbage data, the application should take them back to the form view. All right, the last thing we tested was if a user makes a request on /grades, will our handler method return the appropriate view? Is it going to add the correct model attribute that's needed to populate the view with data? Let's find out. Debug the test. Our handler method does receive the GET request. It adds the grades model attribute. It does return the grades view. And our test reassures us that when a request is made on /grades, our application will behave correctly. This concludes our discussion on testing. React is a JavaScript framework that focuses on front-end development. Currently, our grade submission application combines the front end as well as the back end. Nowadays, nobody writes code like this. The front end should be completely decoupled from the back end. In this lesson, we will explore a design that decouples the front end from the back end. Let's look at our current design. The front end, which represents the graphical interface of our app, was created using Thymeleaf. The back end, which is logic that stores and manages data, was created using Spring Boot. When a request is made from the client, the web server, in this case Tomcat, intercepts the request, and our Spring Boot app prepares the data in some way. Thymeleaf is going to update the view, and ultimately the entire application sends back HTML to the client. We combined the front end as well as the back end as part of the same web application. This is a very outdated practice, and nowadays nobody writes code like this. The only reason I taught you Thymeleaf was so that you can understand the Spring Boot fundamentals. Now that you understand concepts such as field validation, beans, dependency injection, loose coupling, we can move on from this outdated design. The proposed design is one where the front end is completely decoupled from the back end. When a client makes a request, it is routed through a front-end application, which would typically be created using a JavaScript framework like React. Notice here that the front end is its own application, running on port 3000. It receives the request and it routes it to the back end, which is running on port 8080. The back end contains all of the logic needed to store and manage data. The sole purpose of your Spring Boot application is to manage the data in some way. In essence, creating, retrieving, updating, or deleting resources from a database. Once it does that, it's going to send a response back to the front end, and the back end communicates with the front end by sending back data packets in the form of JSON or XML. However, JSON is much more popular and the preferred way of doing so. Now the front end merges the data returned from your Spring Boot backend with its view, then it communicates with the client by sending back an HTML web page. Finally, I want to make a statement. I have used React and I have used Thymeleaf. React is by far a much better front-end technology than Thymeleaf. And in real life, you have to decouple your front end from your back end because a back end can be associated and it can receive calls from many types of front ends. If a client makes a request from the browser, that request is received by a React or an Angular application and routed to your Spring Boot backend. If a client makes a request from an iPhone, the iPhone app built using Swift or Flutter is your front end, which would in turn request data from your backend. If a client makes a request from an Android, the Android application, built using perhaps Kotlin or Flutter, Flutter is cross-platform, it routes that request to a backend. It follows that the backend should be completely decoupled from your front end. Going forward, Module 2 of this course is going to focus on the back-end aspect of web development, which is where Spring Boot really shines. As we move forward, the only concepts I want you to take away from what we've done so far are field validation, 3-layer architecture, and dependency injection. In this lesson, we explored a design that decouples the front end and the back end. Our current design is flawed. I can think of no company that actually combines the front end and the back end inside of the same application. When a client makes a request, it is typically routed through a front-end application, like a React application. The front end, which is its own app, routes that request to your back-end. A back-end component, such as your Spring Boot application, will manage the data inside of a database in some way. It sends back a data packet to the front end in the form of JSON or XML. However, JSON is much more commonly used and is considered better practice to represent your data. Now the front end merges whatever data it receives from your backend and merges it with a view, and then it returns the updated view to your client. In the next lesson, we will look at a practical example where a React application speaks to a Spring Boot application. In this lesson, we'll connect a React front end to a Spring Boot backend. Go to your Spring Boot Bootcamp resources, and if you don't see the React Spring folder, then please download the updated resources from GitHub. And then launch 2 instances of VS Code. One instance is going to launch the React front end, and the other is going to launch the Spring Boot backend. So here's our Spring Boot backend. Don't worry about these annotations right now. We will cover them in the REST API section. Just know that this is our backend, and when a user makes a GET request on localhost 8080/grades, what it's going to do is send back a list of grades that is serialized into JSON data. So let's go ahead and run our Spring Boot backend. Now, don't worry about what JSON means right now. We will also cover that in the REST API section, but just know that JSON is how we can transmit data from one system to another. So here, if I make a request to localhost 8080/grades, and here we see JSON, where each object was serialized into a bunch of key value pairs, and each set of key value pairs is delimited by a comma. So this is JSON, and JSON is the most popular way of transmitting data to a consumer. In this case, the consumer is the React front end. The React front end, if we take a look at the code, now because this is JavaScript and we don't really care about front-end development, the focus of this course will be back-end development. I'm not going to go into too much detail. We don't care about JavaScript in this course, but ultimately, this is the consumer. This front end is going to make requests to our Spring Boot backend. It's going to make a request to localhost 8080/grades. Our backend is going to send back all of this JSON. And this JSON data we're going to use to update the state of the React application, which means over here, what we can do is loop through all of this JSON data in order to generate rows and populate this table, which is eventually going to be rendered by our React application. So ultimately, this React app makes a request to our Spring Boot backend. The Spring Boot backend sends back a bunch of JSON data, and we use that JSON data to populate our view, which is eventually going to be sent back to the client. Now, in order to run this React application, the first thing you have to do is say npm install, and I'm getting ahead of myself because in order to run this React app, you need to have Node.js installed. Okay, once you do, first thing you gotta say is npm install to install our Node modules. And now, ignoring all these deprecation messages, I'll just say npm start. Again, we just want it to run. We don't really care about the latest version or anything. Alright, and this front end can be accessed on localhost 3000. And notice our table gets populated with data that was released from our Spring Boot backend. This is really, really cool. So the client is making a request to our React front end. This is the client, our browser. And the front end, what it's going to do is make another request to our backend. The backend sends back the JSON, and it uses that JSON to populate the table with data. This is how the lifecycle of a request should be. There are three entities: the client, the front end, the back end. Module 2 of this course will purely focus on the back end portion of web development. We will be creating all sorts of web services and APIs. Spring Boot really shines. You will master the art of creating a robust back end, and I cannot wait to see you there. Time to start Module 2. Spring Boot really shines in the creation of web services. A web service operates on some kind of database in some way, and then what it's going to do is share data with a front-end application by sending over data packets in the form of JSON or XML. And Module 2 of this course is going to focus on the back-end portion of web development. We will be creating all sorts of web services and APIs, which is where Spring Boot really shines. You will master the art of creating a robust back end. REST is a set of guidelines that are used to develop APIs. An API mediates the interaction of a consumer and a system. A REST API is just an API that conforms to a set of guidelines. In this lesson, you will learn about REST APIs. Let's start with a very broad definition of an API. It is simply a mediator between a consumer and a system. Imagine that you have a consumer that needs content. The API, what it's going to do is read the consumer's request. And if it's valid, it acts as a mediator by grabbing content from another system, and then it produces a response. Now, a REST API is an API that conforms to a set of guidelines. First of all, REST revolves around the concept of resources. A resource usually implies a piece of data that you can name. Examples include employees, contacts, movies, or products. Here, a database stores a bunch of contacts, and each contact is considered a resource. Now, if a consumer wants to access a resource, they need to specify a URI. The URI, the Uniform Resource Identifier, identifies the location of a resource. The following URI identifies the location of the contact resource, Jon Snow. A REST API should define operations that can manipulate resources. Get retrieves a resource, post creates a resource, put updates a resource, and delete deletes a resource. If a user wants to delete a resource, they need to make a delete request. The URI identifies the resource to be deleted. The API defines an operation that is capable of deleting the resource. It can use the information provided by the URI to delete the resource in question. The resource is most often represented using JSON. If a user wants to access a resource, they will make a GET request. The URI identifies the resource to be accessed. The API defines an operation that is capable of accessing the resource. It can use the information provided by the URI to access the resource in question. And it's going to serialize the data into JSON before sending it back. JSON represents the data in the form of key-value pairs. A collection is a grouping of resources. If the user wants to access all of the contacts, they would specify a URI endpoint that requests all of the contacts. The API would define an operation that is capable of accessing a collection of contacts. And what it's going to do is send back the collection in JSON format once again. When it comes to collections, the JSON starts with a square bracket, such that each contact is delimited by a comma. Perfect, let's start putting all of this into practice. Let's get started. Please launch the starter project by following this path inside of your course resources. Alright, let's start with some key things to point out. The resources that a consumer may want to access is actually just an array list. We're going to define a REST controller that can act as a mediator between these resources and whatever the consumer may be. Number two is, it's actually common practice to create a service interface and use it to define every method that a service implementation must override. Creating a service implementation that implements a service interface helps further achieve loose coupling, because Spring Boot is going to create an object out of the service implementation. We can visualize this by running the application in debug mode, which I had already done prior to this recording. And here you can see, thanks to my Spring Boot dashboard in VS Code, that the contact service implementation exists as a bean inside of the Spring container. And thanks to polymorphism, this contact service implementation is of its own type and of type contact service, which means the bean can be injected over here inside of our controller as a contact service. Now, how does this actually help achieve loose coupling? Well, what if in the future, just follow for now, don't do what I'm doing, I decide to create a better contact service implementation. And let's just copy everything over here. And using your imagination, assume that this is a much better contact service implementation than what we have here. So let's go ahead and comment all of this out. Now I don't have to touch anything inside of my controller because this bean that gets created is also going to be of type contact service. And so it's going to be injected over here as well. The fact that we can make this change and not do anything inside of the controller means that it's loosely coupled. This is a very common design and we're going to be pursuing it going forward. Now let me give you another example of why you'd want to depend on an interface rather than the actual implementation itself. Let's have both classes implementing the interface. I'm going to rerun my application in debug mode. And our app crashes because the field contact service in our contact controller required a single bean to be injected, but two of them were found. There are two contact service beans inside of the Spring container, this one and this one. And Spring Boot has no idea which one to inject. So it gets confused, then it crashes. Inside of application.properties, add a server.port equals 8080. All right. And now let's just say that for whatever reason, I want this bean to be created if the server.port is 8080, and I want this bean to be created if the port is 9090. What I can do is define a conditional based on this property. So here I can say add conditional on property. So this bean is going to be created on the condition that the property that's named server.port has a value, having value. I think we said we wanted this one to be 80. You know what? If the server.port is 9090, then we will allow Spring Boot to create a bean out of this implementation. And we'll go over here and we'll say on the condition that the server.port property is 8080, then we will allow Spring Boot to create a bean out of the following implementation. Conditional on property. And when Spring Boot creates an object out of this class, then its constructor will get called, in which case, let's just, we'll print something like created the better contact service implementation. And if Spring Boot ends up creating a bean out of the following, then its constructor will get called, contact service implementation, in which case we can just print created the contact service implementation. Okay, let's run the application in debug mode. Okay, the port is 8080, so it should have created the better one. Let's just control find better. There you go. It created the better contact service implementation. And if I were to change this property to 9090, we would have to rerun our code. And we should see the following message. Okay, now all of that was to show you that you can achieve loose coupling when a controller relies on an interface rather than the actual implementation itself, we're going to follow what I believe to be a good practice of keeping our code loosely coupled. Now, this is only for demonstration purposes, so we will go ahead and remove it. And we do not actually need this quote-unquote better service implementation. All right, this should be just as we left it before. So I will see you in the next video where we're going to define a get operation that is able to access a resource from the following. See you soon. The get operation is used to access a resource. A REST API defines operations that can manipulate resources, one of them being get, which can retrieve a resource, post, which creates a resource, put, which updates one, and delete deletes a resource. In this lesson, your REST API will perform the get operation. Let's go through the process. If a consumer wants to access a resource, they will make a GET request. The URI identifies the resource to be accessed. The API defines an operation that is capable of accessing that resource. It will use the information provided by the URI to access the resource in question. And it will send back the response in JSON format. JSON represents that data in the form of key-value pairs. Typically, the API would retrieve the resources from some kind of external database, but for our purposes, the contact resources are actually inside of the same application in the array list. So our REST controller is going to act as the mediator between the resources that are going to be here and the consumer that needs access. The array list currently doesn't have any data inside of it, and because we don't have any create methods just yet, what we're going to do is pre-populate it with some data. So here I'm going to say equal to arrays.asList, and we'll create one contact object over here. We will have an ID of 123. We'll call this guy John Snow, and we'll just give him a random phone number of 413-532. We'll just say 943, whatever. We'll create another contact object. Here we'll say 456, Tyrion Lannister, and just change the phone number up. We'll say 613-442-8213, and let's create another resource. 789, the Hound, 897-342-5642, whatever. Okay, so the first thing we need to do is when a user makes a GET request on /contact, so here we'll say GET mapping. When a user makes a GET request on /contact, the URI they specify is going to include an ID. As we wrap the ID in curly brackets, that means we expect the consumer to define a variable inside of their path. The handler method that receives this request, public void getContact, for now is not going to return anything. We'll get back to this. And it's going to access the variable inside of the path as a string. So here we'll say path variable, string ID. For now, we're just going to print the ID that gets passed into the URI. Seem to have a mistake. Oh, silly me. Okay, now before starting this recording, I took the liberty of opening up a terminal. If you're using a Windows computer, open up your command prompt. And from here, the terminal will act as a consumer by making a GET request using the curl command. Now, if a consumer wants to access a resource, they need to specify a URI. The URI identifies the location of a resource. What we're going to do is say localhost 8080 /contact. And now the next thing we input our REST API is going to interpret as a path variable. We want to access the resource with the following ID. Now, nothing really happens. It prints the path variable, and in accordance with the REST API guideline, the URI should identify the location of a resource. But right now, the API doesn't actually do anything upon receiving the location. So based on the path variable, we need to return the JSON representation of the resource that they're requesting. Let's talk about the response body annotation. The response body annotation serializes an object into JSON. If we go back here and return a contact object, let's just import it. Response body is going to serialize the object that we return into a JSON of key value pairs. Now this annotation can be applied at the class level, or it can be applied at the level of each handler method. For now, we're just going to apply it at the level of this method, such that whatever object this handler method returns needs to be converted into JSON. Now, JSON is a universal way of communicating with other systems, and the object we return is serialized into JSON before being sent back to the consumer. So let's go ahead and just copy and paste the first object. We'll set up some methods inside the service class after. So let's just return new contact John Snow. Back to our terminal, we will use curl to make a request. Here you can see the object being returned was serialized into JSON before being returned thanks to the response body annotation. If you don't include it, our app is going to send back a plain old Java object, and the recipient will just have no idea what to do with it. So if we were to curl that, it just shows an error not found. So long story short, JSON is the universal way of communicating with other systems. Which brings me to my next point. REST controller is basically the same thing as the controller annotation plus response body. So if you're building a REST API, instead of including response body to serialize the returned objects into JSON, you can just define your controller class as a REST controller and avoid that step. So remember that I told you response body can also be applied at the class level. And instead of doing that, we can just skip that step and just say REST controller. This naming also befits the fact that we're building a REST API. So if I were to retry this, we'll curl, boom. The response body annotation that exists behind the scenes serializes our object into JSON before sending it back. Here we can see that the JSON is just a bunch of key value pairs. And one more thing, it's not just the object that we'll be returning. We're going to return a response entity, which allows us to respond with data as well as a status code. So here I'm on the official Mozilla documentation for HTTP status codes. These status codes, in my opinion, are useless. You will almost never ever use them. So let's just jump over to the 200 category for now. Now, any response that we send back in the 200 category means that the request was good and it was successful. 200 OK is the most common. It means, hey, we got your request and it was successful. 201 is most often used with post requests, because what it means is, hey, we got your request, it was successful, and a new resource was created as a result. Now 202 means, hey, we got your request, it's a good request, it was successful, and we're queuing it for processing. So we're not going to fulfill your request right away, it's going to happen later. And another common one is 204. This means, hey, we got your request, it was successful, but there's no data to really send back. This would most often be used in a delete request. Now there are others, you can feel free to go through them yourself, but the ones I just presented are pretty much the most common ones. All right, so we'll go back here, and instead of returning just the object, we're going to return a response entity. And inside of generics, you can specify what type of data we're going to be sending back. We're going to be sending back a contact. Okay, now in this case, your contact service implementation already contains a findIndexById function. I set it up for you in the interest of time. Integer streams is something we already covered in the Java course, so I'm not going to go through them here, but it doesn't really matter if you use streams or you could have also used a regular for loop over here. In any case, all it does is it goes through your contacts and finds one that matches the ID. You can use a loop if you want. Inside the interface, what we're going to do is bind any implementation into defining a getContactById method. Contact getContactById. And then we're going to override this method inside of the implementation. We can override getContactById. And here I can just return contact repository.getContact. And we're going to get the contact at the index based on the ID that's provided. Now back here, I can say contact is equal to contact service.getContactById. And then I'm going to return a response entity. A new response entity, and this response entity is going to encapsulate an object. The object being returned will be serialized into JSON as it's being sent back to the consumer, and we're also going to send back a status code of OK. So HTTP status.OK, and the status code OK translates to 200 to indicate that we received the request and it was successful. All right, rerunning my application in debug mode. Back to our terminal, we will use curl to make a request. If a consumer wants to access a resource, you need to specify a URI. The URI identifies the location of a resource. The following URI identifies the location of a contact resource with ID of 123. And the API defines an operation that is capable of accessing the resource in question. It uses the information provided by the URI, which is a string ID of 123, to try and find the resource inside of the array list. It should be able to find it. All right, it was able to get the resource. And now here the resource is going to be serialized into JSON before being sent back. So those are going to be your key value pairs, and you can see that it sends back a status of 200. Now as the consumer, okay, I see that data has been returned, but I can't really see the status code. So what we're going to do is go to Chrome. And we're going to make that same request. We'll say localhost/8080/contact/123. Here we see the JSON that gets sent back. If we go to the developer tools, more tools, developer tools, go to the network, press refresh, we see a status of 200. Now this is a bit inconvenient, so in the next video we'll be downloading a software to make requests from. Postman is a very popular tool that we can make requests from. Go to postman.com/downloads, and there just go ahead and download Postman. Not really much else. Start off by clicking on Home, and we're going to make a GET request from Postman. Now, depending on when you're watching this video, the UI might change, so if it does, it shouldn't be that big of a deal. I trust that you'll find a way to make a GET request. It shouldn't be that hard. So I'm going to go and create a new HTTP request. I'm going to make a GET request such that the URI will locate a resource with the following ID. So we'll say localhost 8080/contact is or has an ID of 123. If I send this GET request, beautiful. The REST API sends back that resource with a status of 200 OK. The beautiful thing about Postman is that it supports GET, PUT, POST, and DELETE requests. So you may have been thinking, oh man, we might need to develop a front end in order to test our API. There's no need for that because we can just use Postman. As a backend developer, Postman can be very, very useful. The POST operation is used to create a resource. An API defines operations that can manipulate a resource. The GET operation retrieves a resource, POST creates a resource, PUT updates a resource, and DELETE deletes a resource. In this lesson, your REST API will define a POST operation. Before we do anything else, go to your Pojo class. Make sure to remove your complete constructor because it's just going to mess everything up. And we're not going to need this anymore because now we're going to be creating objects using a POST operation. So we'll just set this equal to a new array list. All right. Because what we want ultimately is for Spring Boot to use the empty constructor and auto-generate an ID for each object that gets created. We're not going to have those IDs of 1, 2, 3, 4, 5, 6, and whatever. All right. The next step is, you guessed it. We expect the consumer to send a POST request. So what we can do is use the POST mapping annotation to map this request to a handler method. So we expect them to make a POST request on /contact. They're obviously going to be sending over payload along with their request. And what we're going to send back upon creating the contact object is we're just going to send back an HTTP status. We're not going to carry any data back to the consumer. So in this case, when we wanted to carry back data as well as a status, you had to specify the type of data you would send back. In this case, we're just sending back a status, and we're going to call the handler method createContact, and it expects to receive a contact from the consumer. Okay, let's not do anything for now. Inside the interface, what we will do is force the implementation to override a save function. So we're going to say void save contact, and it's going to expect a contact. And now back inside of my implementation, I can just override the following method. Here we'll say contact repository dot save contact. And back here I can say contact service dot save whatever contact gets passed in as payload inside of the POST request. All right, and now we'll go back here and have a look at the 200 status codes. Which one do you think we should send back? Obviously 201. 201 means, hey, we got your request, it was successful, and a new resource was created as a result. Now, usually you'd want to send back the resource that was created as confirmation, but in this case, we're not going to be doing that just because it would add a lot of unnecessary work. Eventually, we'll be using an actual database, not an array list, and that's when we'll do that. But I'm very, very certain that the object will get created and there won't be any issues with the array list. All right, so here I can just return a new response entity that encapsulates an HTTP status of created, status code 201. Okay, what I'm going to do is actually run my application in debug mode. I'll close this console. All right, let's try it out. We'll go back here, we'll go back here and we'll make a post request to /contact, and we need to pass in some payload. So right here, we're going to define some JSON. Let's just copy over the format. Make sure to specify that we're sending over JSON to our API. All right. And the only fields that we're going to include in the JSON payload are the name and the phone number. The ID is going to be automatically generated inside of the empty constructor that we have in our Pojo class. Okay, let's go ahead and send it over. All right, if I press next and expand this, Spring Boot is not able to deserialize the contents of the request body onto our object. But there's actually one last step. And before I explain the step, remember how I told you that the response body annotation that's contained within the REST controller serializes the object that's returned into JSON before it's sent back? Well, Postman, when it sends us data, it's not actually going to send us a Java object, as would be suggested here. It's sending us a JSON data packet. And our application isn't going to magically know what to do with the JSON. And so what we need to do is deserialize that JSON into a Java object. And so what we need to do is include the request body annotation. It serializes the contents of the request body into a Java object. So if we send that same request, you can see that thanks to request body, Spring Boot was effectively able to deserialize the contents of the JSON into a Java object. So actually, if we're going to look at this line by line, let's include breakpoints in all the setters. Let's just step through this, make another request, send it. So first, Spring Boot creates a new object of the contact class. It creates a new object using your empty constructor. The ID field is auto-generated over here. And every single setter that Spring Boot calls matches a field value from the JSON. So the name field matches the set name setter of our object, and its corresponding value is going to get passed in accordingly. The phone number field matches the set phone number setter of our Java object. So just like that, the contents of our request body are deserialized into a Java object. Here we're saving that object inside of our repository, and the API should send back a status code of 201, which means we got the request and it was successful, but it took too long, so as it says, the socket hung up. Let's just send it again. Boom, boom, boom. Sends back a status code of 201. Now this is very nice because on one hand we have an annotation called response body, which is part of your REST controller, and it's able to serialize the object that we're responding with into JSON. And we also have request body, which deserializes the contents of incoming JSON into a Java object. And just like that, we created an API that's capable of communicating with another system. So to recap, the post operation creates a resource. This only leaves two operations, put and delete, so let's get to it. The put operation is meant to update a resource. A REST API defines many operations that can manipulate a resource. Get retrieves a resource, post creates one, put updates a resource, and delete deletes it. In this lesson, we will focus on the put operation. In order to update a contact, we expect the consumer to initiate a put request. So we can use the put mapping annotation to map this request to a handler method. The path that the consumer specifies will contain an ID variable because we need the ID to know which contact to update. And when we update a contact, we're going to send back the updated resource as well as a status code. So here we can say public response entity. And we're going to send back the updated resource for confirmation. I'm going to call this handler method update contact. We can access the path variable of ID over here. And we also expect the consumer to send us the JSON data that's needed to update the resource. We can deserialize the contents of that JSON into a Java object using the request body annotation. And now inside the interface, we're going to force the implementation to override an update function. So we'll say void update contact string ID contact. Now in the implementation, we're going to have to override the update function. And here we can just say contact repository dot update contact. And here we can pass in the index of that contact. And now back inside the controller, we're going to update the resource that matches this ID. So we'll say contact service dot update contact, updating the contact with the matching ID. All right, now let's have a look at the list of 200 status codes. Which one do you think we should send back? I think in this case, let's not overthink it. 200 seems reasonable. 90% of the time, you're going to be sending back a status of 200. It's the most common. We got your request and it was successful. So we'll go back here and return a new response entity that encapsulates the data we want to send back. In this case, I want to send back the updated resource as confirmation to the user that we did in fact make the update, and we'll send back a status of 200. Okay, let's try it out. I'll run my app in debug mode. Oh, wrong mode. I'll put breakpoints on every setter. Oh, I already have them set up. Cool. So the first thing we have to do is actually make a post request in order to have some data inside of our data store. So I will go ahead and create a resource of Jon Snow. Stepping through that and go here and copy the ID value. This is very important. So it's going to create a contact resource with the following ID and save it inside of our contact array list. All right, now we need to make a put request. Now the URI location of the resource, we want to locate the resource with the following ID. Make sure to remove the string quotes. Okay, this is the resource that we want to update, and the contact that we want to update it with, we want to represent it using JSON. So remember that our empty constructor is going to auto-generate an ID, but we do not want the ID of the resource we're updating to change. So we're going to make sure to include an ID key value pair as well. So we'll say ID is equal to the original ID. And so what that is going to do is ultimately invoke the setID setter, which will override the auto-generated ID value with the one that we get from the JSON data packets. Here we have the name, the phone number. Okay, we're good. Now, I believe the original phone number was this, so let's change it up. Let's update Jon Snow's phone number to 9865. Go ahead and make a put request. So Spring Boot received our put request, and the first thing it does is it creates a new object of the contact class. Using your empty constructor, it auto-generates the ID value. Now this auto-generated ID is going to get overridden by the ID we passed in inside the JSON. And just like that, our resource is able to retain its original ID. The remaining contents of our put request are deserialized into our object such that name invokes the setName setter and its corresponding value is passed in. Phone number invokes the setPhoneNumber setter. And if we go back, we see that the Jon Snow resource was actually updated with a status of 200 OK, because after we performed the update, we fetched that same resource and indeed it was updated. The delete operation is used to delete a resource. A REST API can define operations that manipulate resources, where get retrieves a resource, post creates a resource, put updates a resource, and delete deletes a resource. And in this lesson, we're going to create a delete operation. In order to delete a contact, we expect the consumer to initiate a delete request. So we can use the delete mapping annotation to map this request to a handler method. The path that the consumer specifies will contain an ID variable because we need the ID to know which contact to delete. And when we delete a contact, the only thing that we're going to send back is an HTTP status code. We're not going to be sending back any data. We'll call the handler method delete contact. And here we can parse the path variable string ID. All right, and now inside the interface, we will force the implementation to override a delete contact method, void delete contact. It's going to receive an ID back inside of the implementation. Let's override the method. And here we'll say contact repository dot delete contact, and we'll delete the contact at the index. Okay, now inside of my controller, when a user makes a delete request, we're going to delete whatever resource matches the following ID, contact service dot delete contact ID. And having another look at the HTTP 200 status codes, which one do you think we should send back? I think 204 no content is the appropriate status code to send back because we got the request, it was successful, but there's nothing to really send back. The resource was deleted. So we will return a new response entity that encapsulates a status code of, HTTP status dot no content. So that would be 204. Okay, let's try it out. I will run the application in debug mode once again. And what I'm also going to do actually is add 2 breakpoints over here, one inside of save, one inside of updates. And then I'll go back to Postman. First thing I'll do is make a post request that creates the following resource. Remove the ID field because we want it at first to be auto-generated. Let's send the post request. Oh, my bad. Upon sending over a post request, Spring Boot does not expect an ID because we're just creating a brand new contact. Let's try this again. All right, it creates a new object of the contact class, auto-generating an ID, and each field from the JSON invokes a setter. Ultimately, this saves a new contact inside of our array list. Let's just copy over the ID right now, copy value. And there's our updated data store. Okay, now I'm going to go back, make a put request. I want to update that same contact. And give them a new phone number. All right, we'll send that over. Spring Boot creates a new contact object, auto-generating the ID field, but then the ID that we sent through the JSON is going to override the auto-generated ID such that the contact we intend to update retains its original ID. And now here inside of update contact, you can see that the contacts array list already contains a Jon Snow contact, and now we're updating it to have a new phone number. So we just updated the resource and now we're going to delete it. Using that same ID, we'll go and we'll make a delete request. And to delete a contact, the only thing we have to specify is the ID of the resource we want to delete. We do not need any content to send over, so we'll say none. We'll send, we have to complete this request first. And the request sent back a status of 200. The resource was updated. Now we'll go ahead and delete that same resource and it's gone. I should have had a breakpoint for deleting, but trust me, the contact was inside the array list and now it's not. We get back a status of 204, which confirms the success. Okay, last thing I want to do before we wrap up is give the consumer the ability to retrieve a collection of resources. So what I'm going to do is specify one final handler method that expects to receive incoming requests on /contact/all. And this handler method is going to return a response entity that encapsulates a list of contact resources. We're going to call it getContacts. And here what we'll do is just say list contact contacts is equal to contact service dot. We don't have it defined yet. We'll just call it get contacts for now. And then once we retrieve all of the contacts from our data store, we'll return a new response entity that holds the contacts data of OK. Okay, let's go over to our interface and define a list contact, so a function that returns a list of contacts, and this function will be called getContacts. Inside the implementation, we need to override the getContacts method. And here we can say contact repository.getContacts. All right, I think we're all done. Let's test it out. We'll make a GET request that gets every single contact. No need to include a body. Let's just send it over. Oh, we get back nothing, obviously, because we need to create a contact first. As we reran the Spring Boot app, the state of the application was reset as well. So let's just go ahead and make a post request. We'll create a Jon Snow resource. It was created. Let's create a, the Hound resource. Give him a random phone number, create that. Let's create another resource in the name of Tyrion Lannister. Create that. And then if we say /all, and then if we make a GET request to retrieve all of the contacts, it should return the 3 contacts we just created. No need to include a body. We'll say none. Press send. Beautiful. It returns a JSON that contains a collection of contact resources. And the status of 200 reassures me as the consumer that everything is working just fine. All right, we're all done setting up the REST API, but we need to set up some exception handling. You'll be doing all that by yourself in the next few workbooks, so I hope you're prepared. Welcome to Workbook 8.1. I already went ahead and launched the starter project, and I also ran the application. And now our application as it stands is not resilient, because if the consumer were to make a GET request to retrieve a resource with an ID of 123, our application fails. It sends back a status code of 500. Now, if you go here, a status code of 500 means our server or our application encountered a situation it does not know how to handle. In this case, our application failed, it threw an exception, and it sent back a status code of 500. Now, our application, if it were resilient, it would be perfectly capable of handling a situation where the consumer sends an ID that doesn't exist. So the resource not existing should not be deemed our fault. We should be sending back a status code of 400, which implies that it's the consumer's fault. They made the bad request. They need to fix their URI. And we're going to do just that. We need to set up some logic that can handle such scenarios. All right, let's start with task 1. It tells us to create a new folder called exception, and inside the folder, create a no contact exception class. So essentially, we're creating our own custom checked exception. Let's do just that. Create a new folder right over here. And we're going to create a no contact exception, a contact not found exception. It's going to inherit from the exception class. And by doing so, this becomes a custom checked exception that we can throw. Whatever piece of logic throws this checked exception, Java is going to force us to try to run that code and catch the exception if the code fails. So task 2 is to modify the findIndexById function to throw the no contact exception. So here, inside of our service implementation, so currently our findIndexById function, if it can't find the resource, it throws a runtime exception, no such element exception, which implies that our application didn't know how to handle this scenario, and it sends back a 500 internal server error along with the exception that we threw. We don't want to throw a runtime exception over here. What we're going to do is throw a checked exception that forces you to handle it. No contact exception. And here we need to specify that this function throws a checked exception, so anyone that tries to call it needs to handle it. And here we're getting an error. Oh, forgot my new keyword because we're creating a new object of the contact exception class. And so now this piece of logic is prone to throwing a checked exception. So once again, we need to specify that this function may throw a no contact exception. It needs to be handled accordingly. Now this is kind of annoying because now we have to go to the contact service interface and redefine what our implementation needs to override. This is really inconvenient, but bear with me. In the next workbook, we're going to look at a much better method. Anyways, I think we're missing one function. Oh, this one over here. And we'll update the interface here as well. All right, now we got to fix our code inside the controller. Here we need to try to run the code and catch the exception if the code fails. So in case there is a no contact exception that gets thrown, here we're catching the exception and we're going to return a new response entity. The status code we send back is going to be, let's see the status codes that we have at our disposal. Which one do you think we should use? I think 404 makes the most sense. The server cannot find the resource you requested. HTTP status dot, not 404, not found. All right, we'll do the exact same thing here. We will try to run this code. And if an exception is thrown, that means the consumer needs to fix their request. They made a bad request. in which case we're going to return HTTP status dot not found. So when a consumer receives an HTTP status of not found, they're going to automatically know, oh, I'm the one who made the mistake. I need to be the one who fixes my request. All right, doing the same thing over here. No contact exception. Now I know what you're thinking. There has to be a better way. I promise you there is, but let's just do it this way for now. Sometimes it's always good to do it the more fatiguing way so that you can then fully appreciate the more elegant features that Spring Boot offers. So anyways, I think now we should be good to go. Now we need to test our API using Postman. First, we need to create the following resources. This is kind of fun. So we will make a bunch of post requests because remember, post implies creating a resource. Inside the body, don't forget to specify that we're sending over JSON. First, we will create a Jon Snow resource. Boom, it's been created. Then we will create a The Hound resource. That was created as well. Then we'll create a Tyrion Lannister resource. That was created too. Let's just make sure everything is well. Let's make a GET request on /all. Okay, this is perfect. And the next step, we already applied this test case. We're good. Let's request a resource, and the URI will specify an ID that doesn't exist. And perfect, the server sends back a response of 404 not found. This tells us, it says right here, the requested resource could not be found, and it's telling us to fix our request. This was our fault as the consumer. All right. Let's make a put request on localhost /contact/123. And now we get a 400 bad request. So we didn't actually set this up ourselves. Spring Boot automatically knows that the consumer made a bad request because this does not match anything we have in our controller. Our put operation expects a request body. Here we're not passing a request body, so Spring Boot automatically sends a 400 bad request. 400, if you go here, means that the server cannot or will not process the request because there is a client error, a malformed request in this case. All right. Now let's make a request that does include a body. But we're going to specify an ID that does not exist. We get a 404 not found. And now let's make a delete request on /123. No need to include that. Again, it cannot find the resource and it sends back a 404 not found. Please fix your request. Get an actual ID that's in the server. All right, so take-home messages. When a client makes a bad request, we should be sending back 400 messages. We shouldn't allow our application to fail. These error responses should be reserved for actual internal server failures, not for when a consumer isn't able to input the correct ID. Welcome to Workbook 8.2. I already went ahead and launched the starter project. And the first thing it tells us is that in the previous workbook, we were handling bad requests by throwing and catching checked exceptions. This was really annoying because we had to go and modify every single method to throw that checked exception, modify the service interface And then we had to try to run the code in every single handler method here and catch the exception if the code fails. We had to modify the code in many places of our app for a single functionality, and that's not something that I like. In this lesson, or in this workbook I should say, we're going to handle bad requests inside of a single ControllerAdvice class. Let's start with task 1. It tells us to create a new folder called exception, where we're going to create a contact not found exception class and paste in the following code. Let's go ahead and do that right now. I'll create a new folder called exception. I'll create a new file called no contact found exception.java. And should rename this. Okay. So the reason this is a runtime exception is so that we're not forced to catch it wherever it's being thrown. Whenever you throw a new instance of an exception, its constructor is going to be called. We're expecting whoever throws a new instance of this exception to pass in an ID, because it's also going to pass in a custom message into our parent constructor. Now, what does this do behind the scenes if you're curious? If we go to this parent constructor, which passes the message into another parent constructor, which passes the message into another parent constructor, what this does is it updates a field called detail message. So the detail message field is going to contain the message that we ultimately passed in. Our message can be accessed using the getMessage function, which is exactly what we're going to do. But anyways, no need to focus too much on the nitty-gritty. All I want you to know is that whenever this exception is thrown in this manner, throw new contact not found exception, when it's caught inside of our ControllerAdvice, we'll be able to get this message as follows: exception.getMessage. All right. Going back to task 2, we need to modify the findIndexById function to throw this newly created exception. Now, if we go to the service implementation, our findIndexById function already throws an unchecked exception in the name of no such element exception, but in this case, I just wanted to throw a custom exception instead. A custom exception that is more descriptive, and recall the constructor for this exception expects an ID. As this exception is being created, it's going to pass a custom message into the parent constructor, allowing us to access it later on. And finally, because this is a runtime exception, we're not going to be forced to try and catch it, so we don't need to specify that this function throws anything. This makes our lives much easier because now we do not have to touch any of these operations. We do not have to touch the interface. We do not have to do anything inside of the controller. Any exception that gets thrown during the runtime, we're going to handle inside of a ControllerAdvice class. We'll get to that momentarily. Task 3 is to run the application and make a GET request from Postman. Let's do just that. I'll copy this over to Postman right now. It seemed I had already done this earlier, but whatever, I'll just press send again. And we get an internal server error. Now here the consumer is sending a bad request. The ID they're sending over does not exist, and as a result, the application fails. And it throws an exception, an unchecked exception during the runtime. It throws a runtime exception, and then it responds with a 500 status code. The 500 status code must be reserved for actual failures due to unexpected conditions. Like for example, if our application is not able to connect to a database for some unexpected reason, the service might be down, it will send back a status of 500, but the consumer sending a bad ID is something that should be totally expected. Us as developers, we need to anticipate this scenario and ensure that the application does not fail. It must be fully equipped to handle the bad request and respond with a 400 status code, which implies that it's their fault. They are the ones who passed in an invalid ID. So we'll go over here, and it tells us that the ControllerAdvice is a class-level annotation that allows you to define global exception handlers. I'll move on to task 4, which tells us to create a class called Application Exception Handler and apply the annotation we just talked about. All right. So let me collapse all of these, and I'll create a class called application exception handler. This will serve as the global exception handler across our entire application. Anything that gets thrown, we're going to handle right here. All right, and inside of this ControllerAdvice, we can define exception handlers. The exception handler is a method level annotation that instruments a method to handle exceptions. So inside of our global exception handler, we're going to create an exception handler method called handle contact not found exception. So I'm going to say public. And when a contact is not found, when this exception gets thrown, what we want to do is send back a response entity that encapsulates a status code, HTTP status. As you may have guessed it, that's going to end up being 404, and we're going to call it handle contact not found exception. And this method is going to receive the contact not found exception that gets thrown. Now, in order for this method to actually get invoked when this exception gets thrown, we need to mark it as an exception handler that is capable of handling exceptions of type contact not found exception .class. All right. And so when this runtime exception gets thrown, instead of our app failing during the runtime, it's actually going to get handled inside of this method, and we're just going to return a new response entity with a status of 404, which would be not found. All right, let's test this out. And this is a lot better. All right, and here it tells us it would be nice to send the user an error response. So right now it just sends back a 404, but let's send back some JSON. What we're going to do is right over here, define an error response POJO class. So the idea is that we'll be creating an object out of this class, and all of its properties are going to be serialized into JSON. So here I'll just say private string message, and I will generate a complete constructor as well as getters and setters. Here I'll create a new object of the error response class. And the message we're going to pass in is exception.getMessage. So when we threw our contact not found exception and passed in an ID, our exception passed in a message into the parent constructor, which updated a particular field behind the scenes. And the exception.getMessage method is able to grab the contents of that field. All right, and now here it tells us to actually specify a return type of object. Because object is the most generic Java class, we can put anything over here. What we're going to do is send back an error response as well as an HTTP status code. Now this error response, this object, Spring Boot is going to serialize all of its properties into JSON before sending it back to the consumer. So if we try this out, press send, our error response was serialized into JSON such that the message property equals a JSON value of the ID 123 does not exist in our records. Very, very nice. All right. And I think we already did that. We have a 404 not found. Task 8. It would be nice to also send back a timestamp. Let's do just that. Local date time. We need to import it. And as soon as the error gets created, we're just going to set the timestamp equal to the current time. So I think we can do that by saying local date time.now. Looks good. Let's add the usual getters and setters to our POJO class. Okay. And now as we send back the error response, Spring Boot will serialize these two properties into JSON. It does just that, but I don't know about you, this last part is not very readable. So going over to task 9, it tells us that as the property is being serialized into JSON, we can use the JSON format annotation to configure how it's serialized. So here, as you can see, our timestamp is already being serialized into a JSON string. So we're going to do just that. But the pattern we're going to serialize this date to is going to be, well, the following pattern. So I'm just going to go ahead and copy this into our code. Trying this again. And this is just beautiful. Our API is now resilient to bad requests, and it tells the user exactly what they did wrong. As a consumer, this tells me exactly what I need to know to make a good request. Welcome to Workbook 8.3. I already went ahead and launched the starter project. This workbook is going to be a bit nostalgic because we're basically going back to the concept of field validation. So first things first, we need to add the validation dependency. Go to the central Maven repo and just copy it over to your pom.xml file so that your validation dependency can be pulled. We do not need to specify the version for this Spring Boot starter. And I'm going to synchronize the build file. All right, should be enough. Task 2 is to apply a validation constraint such that we need to prevent the submission of a blank name or a blank phone number. So we'll go over to our Pojo class and we will make sure that the name they provide is not blank, such that the message we're going to send back is name cannot be blank. And here, the message we were going to send back is number cannot be blank. Okay. Now you'll recall that the valid annotation is what actually performs the validation process on your object based on the constraint applied to each field. Now, where should we apply the valid annotation, do you think? Well, wherever a contact object is being created and populated with fields. So when this handler method gets invoked, what's going to happen is Spring Boot is going to create a new contact object using your constructor, and then it's going to deserialize the contents of the request body into your Java object, updating your name and updating the phone number. And as the name and phone number are being updated, we need to make sure that they are being validated using the valid annotation. We're going to do this over here. And that should be it. These are the only two places where we need to perform validation. Now, in order to handle invalid fields, we can actually do this in our global exception handler, which is extremely convenient because we already have it set up to handle our runtime exception. All we need to do is inherit from the response entity exception handler class, extends response entity exception handler, and now I can override the handle method argument not valid function. Beautiful. So now you'll remember that after Spring Boot validates the fields of your object, a binding result is going to carry the result of this validation. We studied this in section 3. We can access the binding result through the method argument not valid exception. So for now, I'm just going to print it. I'm just going to say println exception dot get binding result dot get all errors. Here it tells us to return an appropriate status code in the event that there are invalid arguments. In this case, what do you think we need to return? Well, let's go to Mozilla status codes. We'll go to the client error responses because this involves a bad request on the client portion of things. And I would say this is a bad request because the user is passing in invalid data. So if this happens, we're going to send back a new response entity with an HTTP status code of bad request. All right. And now in learn the part, it tells us to create a for loop that loops through every single error inside of the list of errors. So each element is of type object error. Let's just go ahead and import that. Okay. And we can just go ahead and print error dot get default message because this allows us to print a string. Okay, I think we're good to go. Let's go to Postman and we're going to make a post request. The name is going to be Tyrion Lannister. Actually, there should be data in learn the part. Let's just copy that over. We're sending over a bad phone number. And did I even run my application? Silly me, I did not. All right, we'll send over that request and we get back a 400 bad request. So here, if you look closely, it says the number cannot be blank. All right, there's actually only one error, so we didn't actually need to perform the loop. But anyways, we can move on with task number 5. Inside error response.java, we need to convert our message field into a list. I wonder why we're doing that. That's going to become apparent very soon. So we'll make this into a list. All right, we're going to have to modify our constructor. And we can regenerate our getters and setters. Okay, going back over here. Our error response constructor now expects a list, so we can cheat and just say arrays.asList, passing this into a list and then passing it into our constructor. And now let me just go ahead and pass in a bad get request. We'll say /contact. We'll put in an ID that doesn't exist. All right, and now you'll notice that as Spring Boot serializes the properties of this Java object into JSON, the list gets converted into a JSON array type, such that all of the elements that would be contained in this list will be part of the JSON array inside of these brackets. This is really nice. In JSON, there are array types, there are string types, there are number types. So far, we've only seen array and string, but I'm sure in the future we'll be seeing many more data types. Anyways, inside handle method argument not valid, we need to create an error response object and append every error message from the binding result into the list. This makes a lot of sense because if the user were to mess up both the names and the phone number, we would need to send back 2 error messages, not just one. So here what we're going to do is create a new list string, we'll call it errors, I guess, is equal to a new array list. And now I can just say errors dot add, and we're going to add each error or each string into this errors list. And now I can respond with a new object of the error response class. And into this constructor, we can pass in the errors list. All right, let's try this out. You know what? Let's retest the GET request. Everything's still working just fine. Let's test the post request. This time we'll make sure the name is blank as well. Send it over. And this is awesome. As we pass in a blank name and a blank phone number, our binding result is going to have 2 errors. We're appending 2 strings inside of our errors list. We're creating a new error response, passing in that array list of 2 elements. Spring Boot is going to serialize the properties of this Java object into JSON such that this list is converted to a JSON array type that contains each element. All right, and I believe this wraps up Workbook 8.3. All right, welcome to your OpenAPI challenge, where we are going to document our application. Now, we can all agree that coding is the fun part and documentation is pretty boring, but it's important to keep your API's documentation up to date because how else is the consumer going to understand how to use your API? All right, so I will trust that you've already at least launched the starter project and have started working on it. Here, it shows you an example of what an OpenAPI specification would look like. Here you can see a snippet of an OpenAPI spec. It describes what that operation does in detail. It also outlines to the consumer the parameters that this operation expects in order for it to be successful. And if the operation is successful, this is the type of response they can expect. A 200 response such that a contact is successfully retrieved, and it's going to send back a JSON document of a contact. And now the industry standard for documenting an API is OpenAPI. And so computers can read this OpenAPI spec and from it generate human-friendly documentation, and consumers can easily look at your documentation, scroll through, and figure out how to use your API. All right, so as I just described, the purpose of this challenge is to generate documentation for our contact API. And if we go back in our pom.xml, you'll notice that I already included the OpenAPI dependency. Now, in this case, we need to include a version. Otherwise, we're going to get an error. And the reason we never had to specify versions before is because the parent POM already specifies a version number for all of these Spring Boot starters. But if we don't put a version here, Maven will not know which dependency to grab, and it's going to give you this error such that you need to specify a version for it to know what to do. It's not just gonna take a guess. And for this project, I decided to use version 1.6.9. Please use the same version for this tutorial just so that everything is consistent. All right, task number 1 is to run our application, which I believe no, I did not do that. Let me run my application right now. All right. And upon doing so, we're going to navigate to this path and view our OpenAPI documentation that gets automatically generated. So let me go there. And here we see a bunch of JSON that is not formatted properly, and it's really hard to understand what the heck is going on here. So for the time being, I'm just going to create a temporary JSON file inside of my resources folder. I will delete this very soon. So I'm just going to call this, I don't know, openapi.json, paste it over here. And on VS Code, I've got the option to format the document accordingly. In IntelliJ, there should be a set of shortcut keys or a plugin that you can use to format this document. Now, you can also use online tools like JSON Formatter to format it accordingly. Only ever use a software like this if you're testing, apps that don't really matter. But if you're ever working for a company, please don't ever put your OpenAPI spec in a tool like this. This is a very, very dangerous security risk. You're basically giving random people your data, so only ever use this on tutorial type applications. All right, anyways. And here you'll notice what's really, really awesome is that it auto detects every single operation that we have defined inside of our contact controller. So it was able to detect this operation, for instance, and it documents it for us. This operation is can be accessed on the following path. It is a get operation. It was automatically given the tag of contact controller such that every other operation is also grouped under the same tag. We'll visualize that in Swagger UI very, very soon. The operation ID is getContact in accordance with the name of the handler method. Here it documents the parameters that this operation expects, as well as the response that it's going to send back if the request is successful. And the response is going to be a 200 response. Okay, I cannot wait to visualize this in Swagger UI. So what is our next step? Is to go to Swagger UI. Now this says localhost 8081. I don't know why it does that. I'm just going to fix that right now and fast forward the video. All right, the world makes sense again. Let me go to the Swagger UI console. That is going to make sense out of all of this JSON. All right, here we can see all of the operations that we had inside of the contact controller grouped together. Here we can see the request body that our post operation expects, and it also gives us a description of how it will respond. This only expect a path variable of ID makes sense, and it also tells the user what to expect in the event of a successful operation. All right, we're looking good so far. Now task 2 is to configure the OpenAPI definition. Our OpenAPI specification in order for this to actually display an actual title, description, and version number. So what we have to do is create a new folder called config. Inside, create a class called OpenAPI config. This is a class that will contain beans. So you'll remember we'll need to annotate it with the @configuration annotation to mark this as a class that has beans. And inside we'll create a bean definition named OpenAPI that returns an OpenAPI object. Sounds simple enough. This is nothing that we haven't done before. Config, inside we'll create a file called OpenAPI config.java. And now we have to mark this as a class that is going to have bean definitions. And inside we can declare a bean definition that returns an OpenAPI object. So the method will be public. It will have a return type of OpenAPI. Please import the right thing. And what is its name? I guess OpenAPI. All right, and now what we're going to do is just return new OpenAPI, a new OpenAPI object. And by virtue of returning this object, it's going to live inside of the Spring container as a bean. And then Spring Boot is going to manage it behind the scenes. We need to configure this bean to update the title, version, and description of what the API does. So these need to be modified. And I told you in the instructions to consult the Spring documentation. And now you'll notice that I don't like to always just give you the answer. I encourage you to look up the documentation and try to find it yourself, just so that when you're building your own applications, you have that skill. All right, and here you can see, if I go over to this section, all right, and here you can see that you can modify the information inside of the OpenAPI spec by defining a new info object, and then from there you can modify the title, the description, and then the version. And by configuring the bean in this manner, Spring Boot is going to take care of the rest. So let us do just that. As we just saw, we're going to have to say .info, create a new info object. The first thing we're going to modify is the title, which I believe was supposed to be called Contact API. And the description of what this API does will be, it is an API that can manage contacts. .version, this is only version 1 of our API, v1.0. So as your API gets modified over the years, this version would change. Maybe the description might change, but anyways, this is how we can modify the title, description, and version. So let's see if these changes are reflected in our Swagger UI console. And indeed they are. This is looking really, really good so far. Okay. So now task 4 tells us that tag can group operations together. So what I was trying to hint at in the article was that you'll notice all of these operations, this post operation is tagged with contact controller. This get operation also has the same tag, and as a result, they are all grouped together under the contact controller tag. And so for purely the purposes of exploring what the tag annotation does, I gave you the task of splitting each one into its own category, if you will. Obviously, this is not going to be the final product, but for the sake of exercise, let us just assign every single operation its own tag and see how that modifies our OpenAPI spec. All right. So I'm going to go here and we'll say tag. We'll say name is equal to, was this section 1 or section 3? Doesn't really matter. We're removing it soon anyways. This will be section 2 and this will be section 3. And before I jump straight into the Swagger UI console, let me view the documentation /v3, because this is version 3 of OpenAPI /OpenAPI docs. And you'll notice now that if I were to paste in our modified OpenAPI spec and format it, here we can see that this operation now has the tag section 1, this operation now has the tag section 2, so on and so forth, and this should be reflected accordingly in our Swagger UI console, and we see exactly that. But obviously, this doesn't really mean anything. Let us give a more meaningful tag, and here it tells us that tag can be applied at the class or the method level. And with this information, we want to group all of these operations under the tag contact controller. So basically the same tag as before, but without the hyphen, and everything is capitalized. So we'll go over to the contact controller, remove all of these tags, and then we're going to tag every single operation inside of this controller under one group. Named contact controller, and tag can expect not only a name, but it can also expect a description. All right, so we'll go back and we'll say description is equal to create and retrieve contacts. Not the most vivid or thorough of descriptions. In real life, you'll probably have to be more thorough. Anyways, let's go back here. Looking really good. All right, and now it tells us to use the @operation annotation at the method level to provide each operation with a summary and description. All right, so I'll go back over here and we'll say @operation, summary is equal to something, description will be equal to something as well. I'm going to copy this for every single operation. All right, and then I'll go back over here, get contacts. You know what, let me just copy and paste all of this inside of comments. No need to keep scrolling back and forth. So get contact will have the following summary. Description will be the following. All right. For get contact, it will be get contact by ID. That is the summary. And the description returns a contact based on an ID. Fairly intuitive. Create contact will have a create contact summary. And it creates a contact from the payload that you provide. All right. This is looking good. Let's visit Swagger UI to see the changes. And here we see the summary of each operation. This creates a contact. This gets a contact by ID. This retrieves all contacts. And here you see a more vivid description of what the operation does. Now our operations are fairly simple, so we don't have to provide a description that is too lengthy, but just know that you have that capability in the event that you're building a more sophisticated API, if you will. So in task number 7 tells us that API response documents how each operation responds. So here we get an auto-generated documentation that describes how each operation responds. So this operation, this is what it's going to send you back in the event of a 200 response. This is what this operation will send you back in the event of a 200. But the thing is, these operations will also respond with 400 type responses, and we need to document that to the user so that they are aware of what to expect. So we're going to apply this at the level of the getContacts method. So we'll go over here. So this documents the type of response that this operation will send back. Given how we set up our API, this operation will only ever succeed, so it only has one type of response of 200. And that type of response means that you successfully retrieved all of the contacts from our data store. And it also describes the type of content that it can return. So all this says is this operation will return a JSON array of contact resources. So the schema is based on whatever we define inside of the contact class. There's going to be an ID, a name, and a phone number. That's what's going to be sent back. And we're going to be sending back an array of resources. All right, let's go back to Swagger UI. It sends back a collection of JSON documents, an array. All right, let us properly document every other operation. And so getContact, if you'll remember, it is also prone to a 404 error. If getContact by ID doesn't find the ID, an exception is thrown. That's how we designed it, a contact not found exception, which is then caught in the ControllerAdvice, and it sends back an HTTP status of 404. So we need to document that response as well, which we're going to do right now. I'm going to have to import the following. So this one sends back two responses. One type 200, and a 200 response means you successfully retrieved that contact that you were seeking, and this is the type of content you can expect in the event of a 200 response. We're sending back a schema that contains all of the fields of a contact resource. We're going to have to import the following, error response.class. And in the event of a 404, that means the contact you tried to retrieve doesn't exist, and the content is a schema of the error response class. All right, let's check it out right now. So now I can go to contact/ID, and now I can see that in the event of a 200 response, that means the contact was successfully retrieved. And this is the type of data I can expect. This is a schema of the contact class. I can expect a response that has an ID, a name, and the phone number of the resource that I'm trying to retrieve. And if the contact doesn't exist, I can expect a 404. And this is the type of error response that I can expect from that 404. This is just a schema of the error response class that we set up before. All right, let us take care of the last operation, create contact. These are the types of responses that it can send back. We need to document it to our consumers, to our API's consumers. All right, looking good. In the event of a successful response, the contact was successfully created. Otherwise, you'll get a 400 response because you made a bad request. And if you want it to be even more descriptive, you would tell the user, please make sure that whatever name you pass in is not blank, whatever phone number you pass in is not blank. Otherwise, you can expect this 400. But for our purposes, this description will suit us just fine. And in the event of a 400, this is the type of content you can expect in the JSON response. All right, I think we're pretty much done. And that's that. Oh, I'm looking at the wrong one. This is the type of response that you can expect in the event of a successful creation, and this is the type of response that you can expect if you send over a bad request. Now there's one last item in our agenda, is that these responses are all of type JSON. That is the media type, but over here it doesn't really reflect anything meaningful. So our final task was to tell the consumer what type of data they are expecting, and we can do this with the helpful produces attribute. So we can go back here and tell the consumer that this operation produces JSON, and make sure to import the correct thing. In this case, you would want to import org.springframework. I hope you didn't struggle with that. And I think we should be done. All right, now it seems like our application, our API, has been fully documented. A consumer can go through our documentation, read about the parameters that each operation expects, and if the operation is successful, this is the type of response they can expect. Now, obviously, we could have been a bit more vivid in our descriptions to describe to the user exactly how to use our API, but for our purposes, we documented every single operation, we grouped them under the same tag, we gave our documentation a nice title, a nice overall description, and I think this is looking really good. Hello and welcome to another challenge for the REST API section. In this challenge, we're going to write tests to verify that our operations meet the expected requirements. So we've actually tested all of these operations very extensively, but do you ever get that feeling of doubt in the back of your head where just maybe a bug may have creeped into our application? Maybe there's something really small, something very subtle that isn't actually working as it should. Maybe there's a bug. Well, when you write tests for every single type of scenario that may occur, and if all of these tests pass, then you've essentially just verified that all of your operations are working as they should, eliminating any feelings of doubt, and thus giving you peace of mind that your application meets the expected requirements. So in this challenge, we're essentially going to get some peace of mind. And now over here, I made some initial remarks in the sense that in the testing section, you learned how to write unit tests with Mockito. So when we were unit testing, we were checking every single method inside of the service layer and making sure that it returned the appropriate value. In this case, these methods don't really offer any meaningful logic, so we're not going to be unit testing any of them. We're going to skip that. Besides, we've already covered Mockito very extensively in the testing section, so there is no need to demo it again for these meaningless methods in my opinion, but we are going to be writing integration tests because an integration test maps the entire request and response lifecycle. An integration test traverses all of the application's layers from the controller to the service to the repository, and it makes sure that all of these layers are communicating effectively by receiving the request, processing the operation, and returning the appropriate response. We want to make sure that the request and response lifecycle for all of these operations happens smoothly, and that is something we're going to test over here. All right, and here in the starter project, I already set up some methods for you. So this method over here is going to run before each integration test, and what it's going to do is populate the repository with new contacts. And after each integration test, we're going to clear the contact repository because we want the next integration test that runs to start from a clean slate. So if I were to run every single test at once, before each test, it would populate the repository, and after each test, it would clear it in preparation for the next test. All right. Test number 1 is inside getContactById test. We need to mock a GET request to /contacts/1. You already learned how to mock GET requests using MockMVC in the testing section, so I hope you made effective usage of the cheat sheet because we're going to be using the exact same concepts as before. So I'm going to go back here and we'll use the familiar request builder. to mock a GET request. We're going to build a GET request, and the URI, the location of the resource that we want to get, is /contact with an ID of 1. All right, and now I can say MockMVC.perform, and we're going to perform the following request. And now we can make some assertions. So the first thing we have to do is assert that the response returned is 200. See the documentation. Let's do just that. Going over here in the documentation, I can say expect the status to be is okay. You'll remember that in the HTTP status world, okay is synonymous with 200. So let's go ahead and make that assertion. And expect status is okay. Now, by the way, I already made the following import statement for you. If I hadn't, then you would have struggled with the following because this is kind of hard to import for some reason. Now ask yourself, how did I know to make the following import statement? Well, if you go over here, it says that we need to statically import MockMVC request builders and MockMVC result matchers for all of this to work. MockMVC request builders is for building the request, as you just saw. So MockMVC result matchers.star is what grants us access to all of this. How did I know to get the path for MockMVC result matchers? Well, I just went up here and read the documentation. So this here would be my import statement. And as specified by the docs over here, I need to import .start and I need to import it as static. So I just really want to emphasize that reading documentation is a very valuable skill. And if you want to succeed in this industry, you need to get comfortable reading Spring documentation. That's why I never just give you the answer. I encourage you to read the documentation and try to figure some things out on your own. All right, enough of my rambling. I went off on a bit of a tangent. Next thing we have to assert is that the return content is of type JSON, and I believe they already have a working example over here. So let's go ahead and copy it. Media type. Okay, so now we're making an assertion and checking when we make a request to /contact/1, will our handler method return a response of 200, and the data that it returns, will it get serialized into JSON? It definitely will, but we should test for that anyways. And here it starts talking about the JSON path query language, which allows you to query JSON. And this is very useful because the data that gets returned by each operation is JSON. We need to validate the data that it sends back. We need to query the JSON that it sends back and confirm that the data inside is good. So let's just say that the API sends me back the following JSON. Given the following query, this $sign refers to the root element. So the only thing inside this JSON is the following document, which makes this JSON document the root element. And if I want to access a particular field inside of this JSON document, I can just say root element.name. And so what I'm going to have to do now is assert that the name returned by the JSON response equals the correct value. So if I make a GET request to /contact/1, the handler method should return the following object serialized into JSON, and I'm going to need to validate the name as well as the phone number. So I'm going to say, and expect JSON path. This is the type of response it's going to send back. The root element is going to be the JSON document itself that it sends, and we can dot syntax and access the name field of this JSON document. No need for that. And then I can say dot value. We're going to check if the name field of whatever JSON gets sent back doesn't equal the element at index 0 of the contact array dot getName. And so here it's querying the name field of whatever JSON gets sent back, and it's comparing it against the following value. This is the value that we're expecting. And how did I know to use dot value? Again, it's not magic. Everything is documented. You just need to know where to look. All right. We need to make another assertion. And now we need to check if the phone number equals the phone number that we're expecting. All right, so by running this test, it's going to make a request to /contact/1. It's going to grab that contact from the repository and send it back in the form of JSON. If everything works correctly, then this test should pass. And indeed it does. All right, this is looking very, very good. Test number 2, inside get all contacts test, mock a get request to /contact/all. So let me just copy what we have over here. We'll say /contact/all, mock the request, okay. These first two assertions should be the same because we expect both of these methods to send us back JSON as well as a status of 200, okay. Once again, it brings up the JSON path query language that allows us to query whatever JSON response we get back. So assuming we have the following JSON array, and because the root element is an array, we can just say root element.size to count the number of documents inside of this array. And so what we need to do is assert that the size of whatever JSON gets sent back by the following operation has to be 3. Because it's supposed to send us back a collection of 3 JSON documents. So we're going to assert that the size of the root element is 3 JSON documents. And you know what? Let me be more formal and say contacts.length. All right, final assertion. The following query checks for the existence of a JSON document with an age of 25 and a name of Jon Snow. So here we have a collection of JSON documents, and what this is going to do is check if at least one of these documents have an age of 25 and have a name of Jon Snow. If that JSON document within the collection of JSON documents exists, then our assertion is going to pass. All right, you'll notice here that this is wrapped in double quotes, whereas this is not. That is because Jon Snow is a string and age is a number. And in order to embed double quotes into your string, you need to precede it with an escape character. All right, using this information, we're going to make an assertion. We'll just copy this over. All right. And now if I were to make a request to get contacts, I'm not going to go and reopen Postman just for this. What I'll do is go back to Workbook 8.1. This is the type of response that it sends back. What we need to do is check if one of the JSON documents within this collection of JSON documents, does one of them have an ID that equals 2? Does one of them have a name that equals Tyrion Lannister? And does one of them have a phone number of whatever phone number we have in our setup? So here's what we can do. We can check if one of the JSON documents in the returned array of JSON documents, does one of them have an ID of 2? Don't forget to precede these with escape characters. And I hope you put this in string quotes because the ID is a string value. Although it may appear like a numeric type, it is a string. The name we're checking for is Tyrion Lannister. And then we can use the AND operator to also check the phone number, which should be whatever this is. I think we're looking good. Let's make a GET request to /contact/all. Hopefully the returned JSON collection passes all of these tests. And indeed it does. So before running the test, we populated the repository with 3 contacts, and what this ended up doing is it serialized all of these contacts into a JSON array. We checked for the existence of a document that has an ID of 2, a name of Tyrion, and the following phone number. Because that JSON document exists, then I can rest assured that the data this is sending me back is good. I can even make my test even more robust by checking for more JSON documents, but honestly, I'm pretty satisfied, so I'm going to move on to whatever test comes next. Test number 3, make a put request to the following. Oh, I'm sorry, I'm looking at the wrong workbook. Test number 3, inside contact not found test, mock a get request to /contact / an ID that doesn't exist. And we need to assert that the response returned is 404. So when a bad request is made to our API, is this operation going to respond accordingly? Is it going to return a 404? Let's find out with a test. The beautiful part about a test is that you do not have to run your code. You can just run it whenever you want and make sure that everything is working as it should. MockMVC request builders .get, and we're going to make a get request that grabs the contact with an ID of 4. We'll say MockMVC.perform request, and we're going to expect the status after that request is made to be 404. Unsuccessful is not found. Let's run this test. All right, and this is amazing. We tested every possible scenario for the get contact method, and in both scenarios, it works perfectly. All right. Now, for test number 4, we're going to be making a post request, and when making a post request, we're going to have to give our handler method some JSON. And in order to send over JSON, we need an object mapper that can convert any POJO into JSON and send it accordingly. So inside valid contact creation, we're going to mock a post request to /contact. And let's do just that before moving any further. All right, let us mock the post request. Request builder request is equal to MockMVC request builders, and we're going to make a post request with the following URI /contact. All right. Now the first thing you have to specify is what type of data are you going to be sending over? We're going to be sending over JSON data as part of our post request, and after you've specified what type of data you're going to send, the next step is to put in the data that you'll be sending. So here we have a plain old Java object of new student John and 25. And what object mapper is going to do is it's going to serialize this Java object into a JSON string. And our operation is expecting a JSON. So that's going to work out perfectly. So what we need to do first is specify the content type. What type of data are we going to be sending as part of our post request? And that's going to be application_JSON. And then we actually have to put in that content. The data that we'll be submitting as part of our post request, we'll say new contact. It's going to have a name of Rayanne and a phone number of 533, whatever. And now we can use the object mapper. It seems I already auto-wired it before this recording, so please make sure to auto-wire the object mapper bean if you haven't done so already. Then I can say object mapper dot write value as string. And what I'm going to do is serialize this Java object into a JSON string before sending that JSON over as payload in the post request. And so when we submit this post request with its JSON payload, that JSON will then be deserialized back into a Java object, saved into our repository, and it should return a status of created to indicate that the operation was successful. So now that we've defined our request, we've built it, we can say MockMVC.perform. Let us perform the post request, send over all the payload, and we're going to expect a status of is created. All right, let's run our test. Awesome. 4 down, 1 to go. Now, in the event that we send over bad data, what we can expect is for the following method inside of ControllerAdvice to get invoked and send back a bad request status code. So back here, what I'm going to do is copy what we have over here, and I'm going to send over blank data. If I do that, I should expect a status of bad request. It seems that doesn't actually exist. Let me just look through. Oh, is bad request. All right, let's test it out. All right, and we're looking golden. Now I can run every single test at the same time to make sure that everything is working as it should. All right, every single test passed, which means that all of my operations meet the expected requirements. Every single test maps the entire request and response lifecycle, traverses all of the application's layers, from the request to the processing of the request to the response, and the tests pass with flying colors. I can rest assured there are no bugs in this application. I hope you enjoyed the course. If you want to go deeper, make sure to check out the complete Spring Boot Bootcamp, whose link you can find in the video description to cover more advanced Spring Boot concepts like SQL database integration and Spring security. And if you haven't subscribed to this channel, make sure that you do so to stay updated on all of my tech content, and I will see you in the next one.